to JPrime 2023. How do you say it in English? 2023, 2023, whatever. Yeah, welcome. And yeah, I'm really glad to see you all, everybody here. Кажете нещо, бе.
Моля?
Кажете нещо.
So we gotta say something. So this is the 7th edition of JPrime. We had 2 years off because of COVID. We tried to do something, but then the authorities said no. We have 1,200 attendees. We're lying by like 50 people, so it's probably like 1,150, which for us is a world and Olympic record. We have 40 sponsors and 30 speakers. We're pretty proud with what we managed to achieve. And we're
just one thing. Were you happy, most of you, with the registration process this morning, with the printers and with everything? So, big applause for Duchin, who implemented everything.
Duchin did it by himself. We didn't help at all. He tried to ask for help, but we said, no, you do it yourself. We're maxing out the venue, which for us is a great success, We're proud with all the speakers that we managed to invite, so thank you for coming here. And last night we talked about an issue with one of the hotels one of the speakers is staying at, and we have to fix that for next year.
Just so the idea, once again, this time we did really a big job, like, really big investment to bring you the best speakers, as always. So we try always to, to travel around the world, to speak to the speakers themselves, and to invite them and to provide them good conditions to come. So as always, we share the knowledge and we bring you the best speakers to share the knowledge. We usually do this. Thanks.
Mitята is a Twitter guru and pesters all the speakers. So
Mastodon guru and LinkedIn guru and Facebook guru.
Again, everything that we do here is financed by these people. And thank you for all the money and the gold you gave us, so we can organize this and ask for better food or better coffee and
more beer.
More beer and better hotels for the speakers and better dinner for us, or this is the picture from this is what's going to happen. There's a massive tent that's this way, and this is the main hall, and this is the registration is on the lower level.
So Misho again doesn't update anything from the last year. Main hall is called Hall A on the agenda, and the track 2 is Hall B. So anyway.
Okay. Yeah, and the workshops this year are in the same location, but not in that small room, but in the corridor outside.
Behind.
Yeah, so it's here.
So it's going to be more place.
More air. Yeah, no rain, hopefully.
Yeah, so for the workshops you need to bring laptop, but there are 2 workshops that are not actual workshops. They are more like deep dives.
Yeah.
So there will be more in detail, whatever, shopping cart, and etc. So you may not need laptops for everything. So even for today, if you find that the workshop is, let's say, fun, check it. There should be plenty of space this year compared to previous years when the workshop space was always not enough and people were always not being able to go inside.
This is Hall B. It's a large tent. Yes, last year we had some issues with lighting, so it was a little bit bright on the inside. So issues with screen and stuff. We annoyed the people that built the tent to make it as dark as possible, so it kind of feels like home, because we like dark, dry places that have no sunlight. And it's 2-day this year, so it makes more sense to bring a tent and then use it for 2 days, because expensive.
No, don't stop.
The price is the same.
Yeah, the price is the same. There's another thing.
We're saving you money.
The last year, who actually attended last year the Shatra? Yes. You remember it was very hot. We have specially arranged the weather in Sofia because it was very hard to make the air conditioning. So the weather in Sofia is now much better for tent.
Yeah, sorry for the rain. We didn't order exactly that.
Yeah, I will switch to Bulgarian for a second. За съжаление мирише яко на Балатум, ама всичко друго е готино.
Bring your own scent. You can collect stamps from the booths, and then you can get a hat or a cup. So you know what you're working for if you have to talk with other people on the booths.
Yeah, one thing, those of you that know about the game, tried to collect stamps before this session. And the rest that don't know about this game were a little bit handicapped, would be a little bit handicapped if we... Okay, I'm messing up the tenses in English. So yeah, the stamps will be handed out after this session.
No more cheating, sorry.
No more cheating, for those of you that know what it is. Yeah, and you can pick either cup or cap or mug.
Yeah, so they will be given after this presentation, let's say, but I recommend to watch the keynote because the gifts are not that great. And I think the keynote is a lot better. So yeah.
Thanks for the support. We have a co-working space.
Okay, yeah, we have a kind of co-working space, chill area on the right side here. So you can sit there if you want to, relax or type something or work in some cases. Yeah, it's thanks to premium networking, again, for the second year. So to be fair, I've never been to premium networking in Sofia, but in Plovdiv, I can say that it's the best co-working space. So
because Plovdiv is the best.
Yeah, and I'm coming from Plovdiv. That's why I'm like that, because it's super cold in Sofia anyway. But yeah. So big thanks to premium networking co-working, and you can go and actually the people from the co-working are in there. You can speak with them and you can basically thank them from us and from everyone.
How do you know someone's from Plovdiv? They inject it in every sentence.
Or they are wearing jackets or
Yeah, this year we are having free beer as well, and I will kill myself if the beer finishes again. So it will be downstairs next to the registration, free beer for everyone from our partners from Hills. So
yeah, Ivan is that committed, because again, I have to mention Plovdiv, because tomorrow I will be going to Plovdiv after JPrime, so I won't drink tomorrow. So there will be more beer for everyone. Okay, so there will be entertainment zone, which is downstairs where currently is the registration. So after lunchtime today and tomorrow in the morning and again after lunchtime, our Platinum and co-organizers have this opportunity to bring whatever they like and set up an entertainment zone. So you can go down, check the entertainment zone, chill out. Like last year, I have no idea what is this year. But last year, I remember there was some tournament on Mortal Kombat on some PlayStation. There were some Private 8 machines, and there were some stuff. So we don't know what these companies will bring, but you can go downstairs and check. Usually there should be maximum of 4 entertainments at the same time, but some companies might decide to not bring entertainment, additional entertainment.
You can see the agenda.
So yeah, but go downstairs. Don't always stay in the hallway here because it's super crowded. And yeah.
Enjoy.
What was that? These are the zones.
It looks like that. Да, май аз съм го рисувал, така че е много красиво. Да. Това е важно, между другото. Yeah, guys, don't leave because at the end of the day today, I think 20 minutes past 6 is the raffle. So again, our co-organizers, platinum sponsors, and ourselves will give some gifts. So everyone that is in here by the time of the raffle can basically register and can win something. You don't have to do something upfront. So just come, just stay till the end, and you may get some nice gifts. I have no idea what are the gifts, but I've heard that someone will give a gaming chair. So if you are not with a car, I don't know how you will bring it home, but there will be some nice gifts. That's the point. Yeah, the gifts are only for the people that will be here. So if you leave, you are fucked.
You're what?
And you are chairless. I don't know. But stay here. And also tomorrow there will be, after everything, there will be a lot of beer. But today there will be a raffle. I have seen some really nice gifts in the previous years. So don't miss it.
Marto.
Okay, so most of the events that we do, including this conference, are targeted for people that have at least some kind of experience. But, you know, for some time we've been thinking what we do about people that have absolutely no knowledge of Java. And this year we started a completely free Java Academy for people that have zero knowledge of Java. And the main goal here is that in a few months' time, people can just start working as either developers or automation QA. So if you have some friends, some people that ask you, hey, where I can study Java? And you start wondering, can I recommend a free, let's say, course or some training center or university or something like that? You can just send them to this academy. They can just check the content and see if that's their thing. Everything that we do is thanks to speakers from the Java community. So we have different speakers. And everything
is mostly Marto, so please, big shout out for Marto.
With this initiative, we really hope to bring Java more to the people worldwide. For now, all the sessions are in Bulgarian, but later on we plan to do sessions in English. So, yeah, you can check what we currently have. So.
Yeah, there is.
Everything is streamed in YouTube, as I mentioned, and it's recorded. So even though we currently stream all the sessions live, where you can ask questions live, in different platforms like Twitter, Facebook, not only YouTube.
And Twitch.
You can watch the sessions afterwards. Everything is in the Bulgarian Java User Group channel in YouTube. And yeah, so if you have friends or people willing to at least try to become Java developers or even automation QA, you can just redirect them to the Java Academy that we do. For free.
Yeah, when everyone is working from home, everyone has plenty of time, right?
So thanks to Marto again because he donated most of the slides. There's a plan to create the same thing in English in the fall. So again, if someone wants to do a talk, it takes an hour and a half, and there's resources that you can use, so you don't have to prepare your own. And the agenda includes the whole Java stack with the most popular technologies.
Yeah, also the platform that we use, some of you might be familiar with, it's called Moodle. Many universities use it, and we use it to provide automated coding exercises. So it's not only the sessions that we do, but there are also additional materials, coding exercises. So it's, I would say, an end-to-end initiative that we have with the goal to provide a mechanism for people to become developers in a few months' time. So.
By the way, we will finish soon, but there is plenty of space on the right side. And the right side is exactly the same as the left side.
On the left side. For you, on the left.
And it's the, yeah. And then that is the right side. Anyway. So don't be on the left side.
In Plovdiv, that is the right side.
Yo, it's not only the open door. You can open doors here. They are all open. Okay, so... okay, so, there's one thing about all these things. You see, Marto did his conference is for free. What we are doing, this conference, we usually call it the community conference. That means that none of us will have any profit of it. So we do this only for free. All the money that we get from our general sponsors and from the tickets are invested in this event, or if there's some of the money left, they usually go to other events. So we don't get anything for us. So it's only for you that we do that. And the idea is that, all the money that we have spent go to events like, for example, JProfessionals. How many of you have visited JProfessionals this year? Yes. Nice. Okay, how many of you made their way up to Plovdiv to visit JProfessionals? Nice. Okay, now next year I really want to see more hands, because Plovdiv is the best city of the world, of course.
In the universe.
And the oldest, of course. Yes, once again, the idea is that we try to invest the money in your knowledge. That's why all the money that we did not spend here will go to invite other speakers to other meetups. By the way, how many of you have been to Sofia meetups with, he came from Plovdiv up to Sofia. So I see too few hands. I want you to know that once again, we do this for free. We do this for you. So we kindly encourage you to visit more events. There will be more JProfessionals, maybe in different cities in Bulgaria. And we will invite even more famous speakers to share knowledge with you. And once again, we are here to share the knowledge. And by the way, if you want to speak some moment, so you have something to share with us, these events like JProfessionals, like meetups, are absolutely for that. So, дай малко слайдове.
I wanted to show the CFP, but okay.
Okay. Da. So the idea is there is a CFP. That means that whatever submitted talk.
Submitted talk.
Submitted talk. To piše на английски.
Okay, you can submit a talk here.
Yes, if you have something to share, we will help you. We will help you prepare slides. We'll help you prepare the talk. And yes, once again, we are here to share the knowledge, and we do this for free. And we hope you like it.
Yeah, just to add something, because some people don't know. JProfessionals are free events. They're usually in the weekend. The idea is for people, mostly from the Bulgarian community, that have never spoken in front of a lot of people, and that don't want to speak in JPrime because it's English, there are 1,000 people, blah, blah, blah. This is more smaller, friendlier, in Bulgarian.
And JPrime is not friendly.
Chill, especially in Plovdiv, it's a lot more chill. So you can come and speak. You know the joke about what is Ailac? Do anyone know it? So, sorry, we have 10 minutes. So a guy from Spain met a guy from Plovdiv and asked him, what is this Ailac? And the guy from Plovdiv said, and what is this mañana mañana? And the guy from Spain said, well, mañana mañana is, it's a working day, you're at the beach, there are some nice ladies that are making you cocktails and you'll enjoy the day. And what is Ailac? Well, it's the same, but without all this pressure. So there will be usually JProfessionals in the winter in Sofia, and there is usually JProfessionals in the spring in Plovdiv. So on the website that Mishu showed, you can just submit a talk. I don't know, you like Kafka or whatever. You like to debug multi-threaded applications, and you get, I don't know, whatever. Yeah, so you can submit it there, and we basically queue all these talks, and we basically make a JProfessionals.
This is the idea. By the way, we have to have special thanks to Deutschin, who actually, not only him, but even with his family, his wife, his children, the whole family is Java family, they have made this JProfessional Plovdiv possible. So big applause to him, please.
Yeah, so I would like to thank all the people who joined us in Plovdiv, and I hope I'll see many more of you next year. I'll try to make it even better.
Okay, once again, this is the idea. We are community, we are here to share knowledge, so please do this and don't hesitate.
Yeah, if you have any questions, you see a lot of people, including Naiden, with a blue t-shirt. You can ask your questions. Where is the workshop? Where is the toilet? Where is the beer? For the beer, you can ask me. Where is the other hall? So ask anyone with boot issues.
No beer yet?
Because it's not lunch yet. Who drinks beer before lunch?
Leiden.
I woke up at 5 in the morning. So lunchtime for me.
Okay, so
once in your
yeah, thank
life.
you very much. And have fun, learn a lot of things, and see you around today.
Thank you.
Tomorrow. Ти ли ще го представиш?
Аз ще представя. Обаче аз ще стесна надолу.
Добре.
Да, да,
Е, и така.
How was your travel? Everything's okay?
It was very good.
Yes.
Yeah, everything went really well.
Yes. I have something for you. have everything you need, yes? Okay, so please have a seat. Yes, you see, I'm always happy and I really feel blessed to call this person my friend. Yes, and you know, this person makes every event like amazing and real pleasure. And I'm really happy that I believe you're fourth time in Bulgaria already. For fourth time in Bulgaria, my good friend and the good friend of our community, Venkat Subramaniam, is here. And please welcome him on stage.
All right. Well, thank you. Thank you so much for having me here. It's a great pleasure to be talking about what's happening in Java. Pretty exciting times for us, so let's get started. If we can get this computer screen on. While we're waiting for it, how's everyone doing? All right, awesome. This is great to be here in person, isn't it? That's amazing. So let's get started while they try to get up the screen working. I want to talk about asynchronous programming in Java and where things are heading. But let's talk a little bit about a source of confusion. A lot of us, me included, are very confused about this one aspect of concurrent programming. And that is, what is the difference between parallel and concurrent execution? So let's say for a minute we want to think about, what does it mean to run something in parallel? What does it mean to run something concurrently? How do those two relate to each other? So I just demonstrated concurrency and parallelism to you. So I can walk and speak at the same time. I don't have to stop walking to say a few words. I don't have to pause, and I can talk and walk at the same time. That's basically parallel computing. It would be really impolite and potentially really dangerous to health if I tried to drink and speak at the same time. That would be really rude. You probably know some people who can do it. I don't like those people. So I can say a few words, or I can take a sip of water, but I cannot do both at the same time. However, if you give me an hour, I'm going to say a few words in an hour. I'm probably going to empty this glass of water, but within an hour, I'll do both. But at any given time, if you will, either I'm taking a sip of water or saying a word. That's basically concurrency. So parallelism is where, in both parallel and concurrent, tasks continue to execute over a period of time. You're making progress on all the tasks at the same time during that interval of time. But if you draw a slice in time, at any given time, are you doing both, for example, that's parallelism. If you're doing one or the other, that simply becomes concurrency. But what's really interesting here is to go a little bit further into concurrency. We are now interested in talking about concurrency and maybe asynchronous programming. So what does it mean to be synchronous versus asynchronous? Synchronous programming is essentially a blocking call. Asynchronous programming is a non-blocking call. So what does it really mean to be non-blocking? Now, it's kind of obvious if you want to get a data from a database or make a request to a remote server and get some data from a server, you absolutely have to block and wait for the data. You cannot simply say, I made a request, I'm going to go off and do other things. You got to absolutely have the data. You need to get the data to do your work. So you're going to block to get the data always. So what in the world does non-blocking really mean? Well, what I want you to think about is not just the task of execution, but also the thread of execution. So typically what happens in our execution is we've been using threads all along, and we call the threads as lightweight, but the word lightweight is very relative in general. Now, what we typically do is when we make a call to a database or open a file or make a call to a remote server, the task is blocking to get the data back for it to continue doing the operation. But unfortunately, though, the thread of execution is also blocking and waiting. This is not a very effective use of the resource because when you block the thread, you cannot really perform other operations. We end up creating more threads after that. Not a very pleasant situation to be in. But we'll get back to that in just a few minutes. But let's talk a little bit about how many threads should we be creating. Well, that depends on amount of memory, but also the number of cores typically that we have access to. But let's step back and think about this a little bit about what does it mean to be sequential? What does it mean to be parallel? Where does this take us really? Now, when it comes to programming, every one of us who has ever written code, I can absolutely say we have written sequential code. We start learning programming by writing sequential code. A lot of us write applications where we focus on one thread. Now, you may wonder, how do I know I'm writing a sequential application? I'll tell you, it's extremely easy to know it. If you're writing sequential code, when you go to work, people actually smile at each other. They are friendly to each other. You go to lunch together. You actually go home in the evening. That's how you know you're doing sequential application. And you've been writing this application for a while. Things are going really nicely. And then what happens? Somebody tells you one day, we got to improve performance. We got to use multi-threading. So what do? You throw a thread in there. Now you start putting locks and synchronize. And then what happens? That's the day, the last day, there was joy at work. And everybody hates everybody else. Nobody is smiling with each other. We're all grumpy. And we spend late night evenings fixing bugs in code because it runs fast, but really terribly producing results. And you start debugging code endlessly. And one late night, while you're debugging your code, you get very angry, and you apply for this other job. That's called concurrency, right? Well, so that's not a very pleasant experience when you're writing code in concurrent mode like that. So what can we do to really make that better? So in sequential execution, of course, we are creating a program to execute. But of course, when it comes to this, what does the code really do? Let's take an analogy for a minute to think about how threads have been behaving in Java. We all can agree the very first order of business for us when we get to work is honestly to get a cup of coffee. So you go to get a cup of coffee and you realize the coffee machine is empty, and I hope you don't do this. You don't go to the coffee machine and realize it's empty, you turn it on so it starts brewing coffee, and you just stand there and keep staring at the coffee machine, right? And your colleague comes to you and say, are you okay? Don't move, just keep staring at the coffee machine. And they're like, if everything okay, should we call for help? Don't move. I hope you don't do that, right? So what you do instead is, you realize the coffee machine is empty, you turn on the coffee machine, it's brewing coffee, you go to your colleague and say, hey, are you ready for the discussion we want to have about design? Your colleague says, I need about 10 more minutes to be ready. You go start the email client, it's downloading a large email, you're looking at your design document in the meantime, And if I ask you what you're doing, you would say, I'm waiting for the coffee machine to get the coffee ready. I'm waiting for my colleague to start the meeting. I'm waiting for the stupid email to download. And I'm looking at this document at the same time. That's because that's you, the non-blocking you. So essentially, what you want to think about is, what does it really mean to be non-blocking? So non-blocking essentially is where you don't want to spend the time blocking your thread of execution. So your task is going to take some time to execute, and we've been blocking the thread of execution. But what if we say, let the task block and wait for it to get the results and continue further, but I'm not going to block on the thread and wait on it? We'll expand on that a little bit more as we get along, so we'll come back to this idea in a few minutes. But here is what we've been doing wrong, really. We have a thread of execution, and when the thread of execution is blocking, we say, oh my gosh, the thread is blocked. We are not able to get a response in our application. Because the thread is blocked, let's create more threads. Now, think about that logically speaking. The threads don't really work very well, so let's create more of them. That is not a good news for us, but there is a community that loves this idea. Those are called the cloud providers. And the cloud providers love this idea. They're like, keep going. We'll give you more servers and clusters, and that is great because they get paid every time you launch another server, and you can create thousands of processors on the cloud, and this is great for those salespeople. Their people are playing with your people, and they're very happy with the situation. In the meantime, you're screwing the environment. We're not really being efficient in our systems. It's time for us to rethink about this. So when it comes to this, what if a task is going to take some time to execute? What can we do? We don't want to think about creating more threads just because of that, as we know that's not very efficient. So let's rethink about this idea for just a minute. Now let's take an analogy to make this a little bit easier to understand. Let's say you go to a nice restaurant and you sit down in a restaurant. You are waiting for the waiter to come and give you a menu. And the waiter comes over, gives you a menu, and says, what would you like to drink? And you say, I don't know what I really want to drink. What do you have on the menu? And the waiter immediately points to the menu and says, here are the types of drinks I have, that we have. Whatever you like to order, I'll be happy to place the order for you. And you say, gosh, I'm still not sure exactly what I want to order. And what is a good waiter do versus a bad waiter? A bad waiter puts a chair next to you and sits down and says, let's talk about it, and spends the next 15 minutes talking to you. The restaurant will probably go out of business if the waiter does that, right? Because there are other customers who are waiting to be served, and they get really anxious because their orders have not been served while the waiter is sitting next to you. What does a really good waiter do? The really good waiter says, here is all the things available on the menu. Here are the drinks available. Why don't you think about this for a few minutes? I'll be right back, and goes away and serves a few other tables, and then comes back to check on you and says, what would you like? Have you decided what you want to drink? While you're having your meal, maybe if you're like me, I'm drinking water, my cup is empty, and a waiter who is just walking around, immediately comes and pours water and then walks away. It doesn't matter to me which waiter actually poured the water. I am thirsty, I'm happy, I have water to drink. I'm not going to say, you cannot serve water to me, you're not my waiter. That's the best way to get kicked out of the restaurant as well, isn't it? So the point really is, a waiter in a restaurant, if you think about a waiter in a restaurant like a thread of execution, and you ordering the food and eating there is a task of execution, we typically have a really nice scalable system when the task is disconnected from the waiter, the thread, and any waiter can serve you, and you can keep moving forward. So that would be a nice way to really engage with all the different resources in a system. So in order to think about this, let's think a little bit about this idea of coroutines and continuations just a little bit. This is an idea that's been around in our field for a very long time. Some of you may be programming for a few years. Some of the people in this room probably have been programming for a few decades. And those people have been programming for a few decades. I've been programming for about 35 years right now. And one of the things I realized over time is that in our field, we don't have as many new ideas as much as a lot of recycled ideas. But here is something that really blows my mind. Every few decades, we'll give a new name for what we already do and get really excited about it. And people just celebrate this, and you're like, oh my gosh, that's kind of weird. When I came across Amazon Lambdas, people are like, oh my gosh, Lambdas are amazing. And I'm like, when I was a kid, we used to call it data flow computing. And now they call it Amazon Lambdas, and they celebrate it. Similarly, there's a lot of these ideas that's been around for a few decades. I remember as a very young graduate student, I would read these books on computer field in general, and honestly, I would sit there and say, whoa, these concepts are really amazing. I'm reading about these. I really wish I can use them. Well, a lot of these concepts were available in esoteric languages. These languages were used in academics. They were used in a very narrow field. But most of the mainstream programming languages never had these ideas. If fast forward about three decades or 30, 40 years later, and you look at every single language that's in use today has some of these concepts and ideas, and it's absolutely amazing. It's great for me to see my children being able to program things I only could read about in books back in time. So to me, computer science really is democratization of these technologies that what we were only able to talk once upon a time are very commonplace today. One such idea is continuations. This has been around for a very long time. Continuations have been around for maybe 30, 40 years. Most of us never had a chance to use it because mainstream languages never gave opportunity for us to use these. But let's think a little bit about this to understand what these things really mean. So let's say we talk about a subroutine. A subroutine is pretty simple. You call a function, it returns a response to you. That's basically what a subroutine is. It's a function you can call and get a response. You send an input, you get an output. Coroutine, on the other hand, is really cooperating routines. So in other words, you don't typically have a single entry point and a single exit point to a coroutine. You enter a function, you do some work, but you exit the function only to get right back into where you left. In a way, it is kind of like a conversation that you and I could be having. For example, I could ask you, for example, how are you doing? He says he is fine, and I could say, how's the weather? It's Sophia-like weather. I like that answer, right? Very diplomatic, right? So awesome. I like a Sophia-like weather. Does it suck? Is it great? No, I don't care. It's Sophia-like weather. I like him already. But you just saw the coroutine here. We were in a conversation. I didn't say everything and just stop. I asked a question, he gave me a response, we kind of went back and forth. That's kind of what a coroutine is. There is not one entry point, one exit point, if you will. Let's explore this idea just a little bit, if you will, to get a feel for how that actually works in here. I'm going to write a little example here in Kotlin just to get a feel for it. So I want to write a function here. And by the way, the people who wrote Kotlin have an amazing sense of what they want to convey. They want us not only to program, but they want us to enjoy writing code. So that's why they called it fun when you define a function. They want you to have fun when you write code, right? So fun, let's say task 1, you're going to write this right here. And within this task 1, what do I want to do? I want to say print line. Let's go ahead and say in this case, entering task 1, let's say, and in this case, we will print out a thread.currentThread, and we'll print the thread of execution right in there just to see what it's going to do. So you can see in this particular case, we have a function. We said entering task 1. Similarly, we'll say exiting task 1 as well. Similarly, let's go ahead and write one more function here. And this is going to be a task 2, entering task 2 and exiting task 2 as well. So then I say run, and I'm going to then say over here a task 1, let's say, and we'll call the task 2, and let's go ahead and print out right here, and we will say called the 2 tasks, and we will also print the thread dot, let's say in this case, the current thread as well, and we will print that information so we can actually take a look at what it's telling us. So a fairly simple code here, as you can see, nothing really exciting. So we call task 1, we call task 2, and we are printing out that we executed the task. So that's very simple code here, as you can see. So nothing really exciting. But I'm going to go a little further with this right here, and I'm going to say import Kotlin x.coroutines, let's say. And in this case, well, let's go ahead and bring up not a run in this particular case, but we're going to turn it around to, let's call it as run blocking, like so. So what does that do? Well, run blocking starts a coroutine, and it's going to block and wait for the coroutine to actually finish. So it's calling task 1, calling task 2, and then it's printing out that it called the 2 tasks. Again, nothing really different, the same output as before, a little boring, I know, at this point. However, I'm going to call this as launch, like so, and I'm going to call this as a launch here as well, and you can see there is a little bit of a difference already in the output. What you notice is, notice it first on the first line it said, call the 2 tasks, it says, then it says entering 1, exiting 1, entering 2, exiting 2. So what does that really tell us? It tells us that these 2 calls that you see here are really non-blocking, absolutely, because the thread did not wait for those to execute. It simply fired a request to task 1, fired a request to task 2, and executed the print line, and it's now waiting for task 1 and task 2 to finish. I want you to think about this as an analogy. Think about the good old Windows program you ever wrote, maybe a Swing application, maybe a Windows application. What did you do? If you press on a button, you don't really act on it right away. Pressing on a button, for example, would put a message in a queue, and when your task is completed, the thread will, on idle, pick up a task to execute from the queue and run. Think about this in a very similar way, that your code is executing, it finishes the current work, it picks up the task 1 to execute, and then picks up task 2 to execute. So far, so good, isn't it? But at the same time, though, I want you to pay attention to the thread of execution. Notice the entire code is executing in the main thread. We are not creating multiple threads right now. It's one thread that's executing the entire code, but it ran the last line called the task 2 task. It ran task 1, ran task 2. However, I want to get to this function again, but I'm going to call a yield function. And similarly, I want to call a yield function in both of those functions. So what does the yield function do? The yield function is just one example where it says, I am doing some work, but I'm going to take some time. I don't want to block and wait on the thread, so I'm going to yield. I'm going to let the thread go, and when the thread is done with other work, it can come back and continue further. So yield is a way for you to be really nice. Imagine the nice command in Unix. When you say nice, your process is being really nice. It gives priority to other processes to execute if they want to. Think about it in a very similar way. Now, of course, this function here is a non-blocking function. I really wish the developers of the Kotlin language thought about it a little bit when they named these things. As I said before, I really appreciate them calling it function. Imagine if they had called it non-blocking fun. That would have been amazing, isn't it? Who here doesn't want a non-blocking fun, right? That would have been amazing. But they didn't think about it, unfortunately. They gave a very poor choice of a word. They called it suspend fun. How sad that really is, right? So this is one of the requests I have for them, is to rename suspend to non-blocking. That would be really awesome. But anyway, we have a suspend function, and we are saying that this function is suspendable, if you will. That's basically what we have here, is we marked it as a suspend fun. So when I execute this code, however, notice the output of this code. It is very different from what we saw earlier. Notice from the output, you called the task to task. That was the very last line that executed. But notice you entered task 1, but you haven't exited yet, but you have entered task 2 at the same time. And then you exit task 1, then you exit task 2. But did you notice the entire code of execution is within main, as you can see in here? So what does this particular code example show us? The code shows that we have 3 different tasks, for example, that we want to execute, but the thread doesn't block on executing any one of those tasks. So it called the task 1, it called the task 2, printed the last line of code, then it went into task 1, it said entering task 1, but didn't quite finish task 1, the thread switched over to execute task 2. In the middle of executing task 2, it switched back to task 1, finished the task 1, and finished up task 2, and it's the same main thread that's going back and forth, just like you didn't block and wait on the coffee machine while the coffee is brewing. You went on to check on your colleague, opened up your mail client, you were looking at the document, the non-blocking you, this is the non-blocking main. So this illustrates how the non-blocking code is working. Now, of course, this poses a bit of a challenge, if you will. For example, if I say value equal to 7, and notice I put value equal to 7 right there, but in the end of this code, I'm going to print line the value right there. So when I execute the code, notice that the output shows the value of 7. However, what is really intriguing is you came into this function, you executed this line of code, and then we left the function right there, only to re-enter the function right here later on. And you saw that in the output. You entered task 2, but you exited task 1 before you exited task 2. So the question is, how in the world does this code know what the value is after you left the function and you re-entered it? Now, this is an idea where imagine for a minute that you work in an office where, you don't have a specific desk to work in, let's say. So just like this particular, desk here, this is not a place where I work continuously. Maybe I speak now, maybe I come back and speak another time. But what if I really want to save something and I want to use it again? Typically, what you do is at the end of your work, you gather up your stuff, maybe put it in a box, and it has your name on it. You put it on a shelf and you go away, and maybe a week later when you come back to work, you can take the box and put your stuff again and get your workstation ready, and you can move forward. So in other words, we need some way to save the data as you go back and forth. And I know what you're thinking in your mind, thread local. That's a bad idea because a thread is no longer going to be the same thread that executes, for example. So how do you really make this work? This is where this idea of continuations really come in. So what are continuations? Continuations are data structures that can remember the state of a previous call and can continue from where you left off. So this is basically useful to build a conversational state. For example, I can go to this gentleman and say, what was the last question I asked you? And he's probably going to remember and say, you asked about how beautiful the weather in Sofia is. Well, how does he know this after such a long time? Well, that's a conversational state he remembers, and that basically is called a continuation. Now, here is a clue, though. You understand what a continuation is, but what if I tell you as a programmer, you need to be writing code with continuations? The first thing is, you're not going to like it because that's a lot of code for you to write. And the second thing is, everybody else is not going to like it, because we're going to create bugs in code, and the code becomes hard to maintain. This is not going to be fun. So all these ideas of data structures are amazing, but you want them to work in the shadows for you. You don't want to deal with them directly in code. You want them to be there behind the scenes and do the work for you. Let's just take a look at that really quickly, just to understand and appreciate this particular idea, if you will. So let's go back to this code here for a second, and let's try to write a very simple code, let's say a compute function, and where the compute function takes an integer and simply returns, let's say, n times 2. So nothing really exciting in this function, as you can see. Now let's go back over here. Let's do Kotlin C-JVM and compile this code just for a minute. Once we compile it, you can see the Java bytecode being created. Let's do Java P minus C minus V. All those options are aliases on my machine. So I'm going to say sample.class and look at the bytecode being generated. Only to tell you nothing exciting going on here. So here you have a compute function, as you can see. The compute is taking an integer as an input, returning an integer as an output. Nothing really exciting, just as you would expect the function to be, nothing really going on. But let's go back to this function again, and this time let's change it to operate rather than compute, just to give a different name for us. So the only difference between these two functions right now is the name is different. However, I'm going to say suspend in front of that particular function. That's the only difference for all practical purposes between these two functions, as you can see. Now let's go back and compile this code one more time. Take a look at the bytecode at this time again and see what we see as a difference between those two. Once again, you notice the compute is just the way it was. Takes an integer, returns an integer. However, what about the operate function? If you look at the operate function, though, notice it's taking continuation as an argument. And that's fundamentally different from the code we saw. So when you mark the function as suspend, the compiler realized that this is not a subroutine. You're not going to enter this function and exit in the end. You're going to have a conversational state with it. So automatically the compiler interjected a continuation for you quietly behind the scene. So every time this function is executed, the continuation will manage the state of the conversation for you, and it's going to work behind the scenes, which is the right way to do, because if you and I were to write this code, it's going to be error-prone, tedious, and it's going to make a mess out of what we do. But a compiler is very capable of doing it, so we enjoy the benefit of the concept without being tortured by the data structure that we have to use. Life becomes really easy, if you will. So that kind of shows us the power of this for us. So where does this really take us? Now, again, like I said, this ideas of continuation has been around for a long time. This is not a new concept or a new idea, but more and more languages are beginning to implement it. And this is where the future of Java really comes in. So starting Java 19, we have had the concept of virtual thread as a pre-release, and as of September, the Java 21 is going to have this as a full feature in the JVM. Now, the benefit of having this concept in Java is not only you can do this in Java, it really raises the bar for all the languages on the JVM. And this is where the power is going to come in. But what does it really provide for us? Let's take a look at an example of this to see what this idea provides with a little example. So let's go ahead and create right here, if you will. In this particular case, let's say we want to create a function, let's say as public static. We'll call this as a do work function. And in this function, all I'm doing is to say try thread, let's say, dot sleep, and let's ask it to sleep for about 5 seconds right there. Okay, maybe about 2 seconds, if you will. And let's go ahead and say a catch and exception, let's say EX, and we will simply go ahead and close that out. So our do work method is pretty simple, as you can see right there, nothing really exciting. I'll give a little 5-second delay, but let me say over here, a max is equal to a 10, let's say, and I'm going to say a for int I equal to 0, let's say I less than max and I plus plus, nothing really exciting, and all I'm going to do here is to say a new thread, and let's go ahead and call the do work method. And then once we call the do work method, let's go ahead and start the thread of execution. A fairly simple code, as you can see. And then when it's done, we will output right in here that it is actually done. And we will say done right there, if you will. So a very simple code, nothing really exciting. And if I execute the code, you're going to see the done being displayed at the end of 5-second delay, and there you go. So that worked, not a problem. Now, what does this code actually do? Not a whole lot. What does this function do work do? Really nothing. It's sleeping. Now imagine those of you who are parents of young children. Maybe you have toddlers at home. If you're too young to have a toddler on your own, it could be a cousin or a nephew or a niece. And if the kid is, usually kids are very energetic, right? They run around and you can never keep pace with them. And eventually by afternoon, the kid says, I'm going to take a nap. Okay, kids don't actually say it. They get cranky, and you kind of know they're going to take a nap. So if the kid is going to sleep, what is the worst thing you can do as a parent or as a caretaker? You say, kid, you want to sleep? Great idea. Let's sleep together. No work will ever get done. The moms and dads in the room know this, right? So what do you say? Whew, finally, you put the kid to sleep, and that's when you get your work done. Well, this thread is a very poor parent. It says, you want to sleep? Great idea, let me sleep with you. And it sleeps with the task of execution, and you know that's not going to work really well, right? So what's the problem? Notice we ran this code, not a problem. It said done. That was easy. What if I said I want 100 threads of execution? That shouldn't be really that hard either. 5 seconds later, you're going to see done. That worked really well. What if I said I want 1,000 threads of execution? Hey, 1,000 is still not a big number, right? Relatively speaking. 5 seconds later, it says done. But what if I say I want 10,000 threads of execution? Now you can see it actually blew up on my face. What does it say? It says out of memory error, unable to create thread, active native thread, possibly, it is not even sure what happened, right? Possibly out of memory, right? So what is wrong with this code? You don't do a whole lot in this code. You're just sleeping, and you created 10,000 tasks, and if you turn up the volume, you will hear 10,000 threads snoring, right? Because they're all sleeping with the task of execution. So when your task is blocking, your thread of execution is blocking with it. Not a very good use of resources. This was the reality in Java that we used. So what can we do differently? Well, now Java has super lightweight threads. You say, whoa, wait a minute. Why do they call them super lightweight threads? Well, the reason is the word lightweight thread is taken. So they have to come up with something different, so they called it super lightweight thread. Well, threads are lightweight. Now you have super lightweight threads. So what are super lightweight threads? Well, these are threads that are managed by the JVM and not by the operating system directly. These are your virtual threads, if you will, that you're really creating. So virtual threads, unlike real threads, are purely managed by the Java virtual machine, and they map over to the underlying real thread when the execution happens. However, when a task of execution is blocked, you don't want the real thread to block with it, just like that waiter in the restaurant. So when your task is blocking, your thread detaches itself and says, you can take your time to finish up and wait for the response, but let me go take care of other things for you, and then it can come back and execute the code of execution, and it can move forward at that time. So when virtual threads are blocked, the task is waiting, but not the underlying thread of execution. So as a result, if you go back to this code, notice with 10,000 threads, we could not really execute it. So what do you typically say? If you want a lot of threads, sorry, you cannot run on this machine. You need to really run this on a cluster of machines. So now we are running this on a cloud, and I'm not telling you that cloud is a bad idea by any stretch of imagination. That's not my point. But using a cloud just because your threads don't scale is not a greatest of idea, because that's not a good use of our money when we are trying to scale horizontally because the threads are not working the way they are supposed to. So in this particular case, let's get back to using 10 threads again just for a minute. As you know, this is using a regular thread. But I'm going to go back and make exactly one change to this code. So right here, as you can see, I'm going to say a thread, but I'm not going to call a start on the thread right now. And instead, I say thread.start virtual thread, and I'm going to ask it to start a virtual thread rather than an actual thread like we did in the past. So notice it says done, but what if I go back and say 1,000 threads like I did before, and you can see in this case 5 seconds later, it was done, not a problem, it was able to create 1,000 threads. What if I ask it to create 10,000 threads? Remember, it couldn't do this earlier with regular threads. With virtual threads, that is not a problem. It was able to create. What if I asked it to create 50,000 threads rather than 10,000 threads? As you can see in this case, that was not an issue as well. What if I ask it to create 100? I feel like I'm running an auction all of a sudden here, isn't it? But I can go back and ask it to create 100,000 threads, and Java says, why don't you give me something a little bit more challenging? Well, okay, what if I asked to create 1,000,000 threads? Do you feel your pulse rate going up right now? You're like, oh my gosh, 1,000,000 threads, are you serious about it? So why not? Let's ask it to create 1,000,000 threads right now and see what Java tells us. And you can see in this case, 5 seconds later, Java is like, why don't you give me something a bit more challenging? So what if I asked you to create 2,000,000 threads right now? And you can keep going with this, and you can ask the question, how many threads can I create? And the answer is very simple, as many as you want to. Isn't that the answer? That's the right answer always, right? Like the beautiful answer he gave, how's the weather? It's Sophia-like, right? So that's exactly as many as you want to. It doesn't really matter. It depends on what you want to do. That shouldn't be the constraint by the system. So essentially, these became your operating system levels are disjoint from the virtual memory threads. But where does this really take us? What are we really benefiting from in this particular case, you might wonder. And the answer to that question really is, I want us to think about a little bit about where we are and where we are going with this. Now, the threads don't have to be blocking, and what's the benefit of doing so? I want you to think about the long past of Java. In the past, what did we do? You write your code, sequential code, everybody is smiling, everybody is happy. One day you throw in threads, and what happened to your code? Your code just turned into a monster, isn't it? You no longer recognize your code. You're in this nostalgia. When we were writing code in the past, how nice the code was, what just happened to this code? So in the past, you can say the structure of, you can say, imperative style, you can say the sequential code was very different from the structure, if you will, from the structure of imperative style parallel code. One was nice, the other was a monster. However, in starting from Java 8, something really happened. And that is the structure, if you will, of functional style sequential code, you can say is the same as the structure of functional style parallel code. And a lot of us have benefited from this. And I would say this is thanks to, what was that? That's right, the Stream API. So thanks to the Stream API, we were able to benefit from that. That was very awesome. But there's one other change that happened in Java, if you remember. So from Java 8 onwards, the structure of functional style, but you can say synchronous code, is the same as the structure of, again, functional style. You could say asynchronous code. And again, this happened in Java 8, so asynchronous code. And in this case, of course, thanks to, anyone wants to take a guess? No? Completable future, isn't it? So a completable future really gave us that capability. But did you notice the unfairness here? The sequential code versus parallel code is awesome if it is in functional style. But what if it's an imperative style of programming? Don't get me wrong, I love functional style of programming, but it's really hard to deal with impurities in functional style. It's really hard to write code in functional style when you have a lot of exceptions and multi-level exceptions. The code is not as pleasant to deal with. Now we have an amazing opportunity. Let's rethink about what this idea provides for us in here. So to understand this, let's go back and write a little function. We'll call it as a fetch. And what I'm going to do in the fetch is I'm going to take an index as an argument, but I'm going to output right here, let's say entering, and we will output the index plus, and we will also output the thread, let's say, dot current thread, and we will output that right there. That's entering. Then we'll put a try block and a catch block here as well for now. And let's also say over here, length is equal to, and we will say files, let's say, dot lines, and paths dot, let's say, get, and the sample.java file that we have with us, and I'm going to call that one. And once we get the data, let's go ahead and print it out right here. And let's go ahead and say, we'll call it as data, or we'll call it as result, and index right there. But we'll also print out, well, the length is not really that exciting, so we'll just say result and print that. And then finally, we will say, catch, and we'll put the index in there. But how about putting one more here, finally, and within the finally, we'll put that as well, and instead of catch, we'll say finally. So I'm going to go back to this code, and we call that as a fetch function. Let's put a little value of 10 right there, if you will, and let's go back to this code right here. And in here, let's go ahead and say right now, in the for loop, new thread, let's go ahead and say, in this case, an int index is equal to I, and we will call this function fetch with the index given, and let's do a start on it so we can see what it's going to do. Now, clearly, you're performing an I/O to read a file. You could be reading a file, you could be reading a database, you could be sending a request to a remote server, to a microservice, a web service. Who cares, right? You're doing some I/O operation. That's what you're doing. When you look at the output of this code, what are you going to see in here? Let's go ahead and say this is going to be I/O, and we'll bring in a nio.file as well right there for us to use. Let's take a look at what this code is going to tell us. Notice in this particular case, you are entering 0 with thread 0, 1 with thread 1, and 9 with thread 9. that is easy, right? The numbers map over, they made it really easy for us. Look at the results in here. The result is 0 is thread 0, and you can see that in this case, the result of 8 is thread 8, so you kind of see the same mapping. In the finally, the 1 is thread 1. Similarly, 0 is thread 0. So what do we infer from that? The threads are blocking and waiting for the execution of the code. And as a result, when you perform I/O, the task is blocked and the thread is blocked with it as well. That's the life we've been living so far. Let's change that a little bit and see what this is going to do. And notice, I am not changing the code in the top. The code in the top is exactly the same as it was. The only change I am making right now is to say thread.start virtual thread, and then I'm going to go back here and remove the start because we already started the thread of execution. Now let's go back here and take a look at the output of this code. You can see entering 3 with pool worker 4, so 3 and 4. Look at 7, 7 and 8, so 3, 4 and 7, 8. Let's look at the result of 7, if you will. That's a worker 3 at this point. And what about the entering 3? So let's look at the index result 3. That's a worker 4 again. But what about the result of 0? That's a worker 2, whereas entering was a worker 1. And similarly, when you look at the finally, you can see the 0 was worker 7. So what does that tell us? You're not really using the same thread of execution. It's not blocking and waiting. It becomes a non-blocking. So what's the moral of the story from this particular experience? We can say from Java, okay, 21 or 19, if you really want to consider that, you can say the structure of imperative style a synchronous code is the same as the structure of, you could say, imperative style, a synchronous code in this particular case. And of course, you can say this is thanks to Project Loom, as you can see in here, or to virtual threads. So this really opens up a new area for us in terms of how we can be a lot more effective in terms of resource utilization. As a result, we are writing more and more code today that is benefiting from asynchronous calls, and this is in the right direction for Java to introduce this idea of continuations, if you will. So where does this really make sense? It makes really good sense when you are dealing with I/O. Virtual threads don't help you as much if you're doing computations because your threads are busy anyways, but if you're performing I/Os, you don't have to block and wait. So this really brings up a non-blocking I/O. So to summarize, we can benefit from a lot more, a better use of resources. And like I showed in the example of Kotlin, in Java, we're using continuations as well, and that really makes it easier for us to do better multi-threaded code with a greater efficiency, and that's the new world we are moving towards. I really hope that was helpful. Thank you so much for this opportunity. Thank you. Enjoy the conference.
Okay, now we have 10 minutes break, and then is the next session.
That could have been us. We can ignore what our name is. That could have been us. Living naked and famous, just another dream.
Okay. Please take your seats because we have to be in schedule. Okay, people are coming, but I can still introduce you a very amazing person. You know who this guy is? This is Otavio, and he's the top contributor for Jakarta E this year. Big applause for that. Yes, all the way down, almost from Brazil. Yes, and I'm really happy. He's my friend, and I'm really happy he's finally here in Bulgaria. And after this talk, you will become Jedis of persistence. Now, please make those people Jedis. Otavio, enjoy.
Okay. Thank you. I'm glad to be here. Super happy to talk about data. And yes, I have 3 hours of conversation, but I forget to do the backup, so I just have 50 minutes what data left. But anyway, let's do a little bit explanation about Java architecture, how we handle with that, and of course, talk about Jakarta, right? The specification around Java and enterprise architecture. The first questions that we usually do when we talk about data is why. Why data is such much important thing that we need to handle that. And yes, because data right now is our business goal, is our target, right? Is where the information is there, is how we get the soul of the application. It's impossible to imagine application without data right now. And of course, right now we are using and exploring several buzzwords like microservice, Kubernetes, and so on. And most of the time, when we talk about scalability, we mention the idea of being stateless. But of course, this state needs to go to somewhere. And probably is around data. And when we talk about data, we also apply the idea from new opportunities like data cloud or machine learning operations and even new products from data. For example, in Brazil, we have the biggest Latin American bank, that is Itaú, who decided to start to sell wines because they checked the credit card. They could see that, okay, right now we have several wine lovers in Brazil, and they decided to sell wines, and it becomes the biggest winery in the whole country because they could see the data through this information from users, right? To explain more about data, let's achieve our goal using 3 steps. The first one is business. Basically, when we talk about data, it's about the reason that we're doing that, the goal, right? And every time that I talk about the business, the goal to achieve with data, I remember the quote from this amazing book, The Modern Software Engineering, by David Folland, that explained for me, so far, the best definition of software engineering. That is, an application of empirical scientific approach to find efficient economic solutions to find issues in software. And every time that we talk about domains, that we talk about design, it's impossible to don't mention DDD, right? It is still a buzzword that we love to do. Indeed, when we talk about microservice, we can see several books, several definitions that say, okay, with DDD, we're able to do microservice, especially because we're able to break down our domains and avoid any kind of bundle context. When we usually talk about DDD, we most of the time believe that DDD is a framework. And of course, as you know, it's not true. You are able to do a communication to take the domain, your knowledge, and convert to software. But let's Let's do a little bit more code right now. It's become boring. Let's imagine a scenario. I'm Brazilian, so I'm supposed to enjoy soccer, which I don't, sorry. And I'm supposed to enjoy coffee, which I don't as well. Just drug dealer, maybe. But I don't supposed to do that all life. I'm lying, so don't put me in jail. But let's imagine a scenario where a soccer team and want to store that information, right? And of course, we're talking about DDD. Let's convert our domain to the software. The first one that I'm going to write is the player, the soccer player, where we're going to do the basic things, the ID, right? So the ID, or we can have the username, whatever you wish. We have also the name. We have the city where this player comes from. And finally, we have the salary, right? And we need to define one way to represent this little guy here. Of course, we have several ways to do that. Okay, let's imagine big decimal, if you are familiar with effective Java, or you can use even int, where you work with cents. But when the soccer team, you're able to receive several types of currencies, right? I'm able to receive money from US, from Europe, from Brazil, and so on. One thing that we can do is create our value object to represent that. And the idea of exploring DDD is, again, convert the knowledge to software. The DDD has two parts. The first one is the strategic. The idea that we have ambiguous language. We also have the map context and the bounded context. So the language, the context, and the map context. And based on that, we're able to go to the tactical way where you convert that in patterns, right? So what I'm doing here is my empty, where I have my player. Right now, let's create a value object to represent money, right? And by the way, it is a good case to explore, for example, records. There are several discussions around, oh, I can use a record just for DTO. And come on, that's not true. You are able to use and explore record design to several things. That includes the value object. For example, here, I do have my money. I have my currency from Java itself, as you can see. So my currency. And I do have my big decimal as value. Come on, Otavio, but my currency should be valid. I should not be able to create this money if without both, right? I should not be able to create money if without currency and if without big decimal as value. Indeed, we're able to do that with the compact constructor. So if you wish, I'm able to come here to come here and also do these validations, right? So required no new, I'm able to do this validation. I can put the message. Currency is required. I will use the power of copy-paste. That is the Jedi lesson number 1. So always use copy-paste everywhere. So I will come here. Right now, what I do have, I have validation on my currency. So right now, every time that I create a money, what I can do is make it valid. Another point is, on my domain, it doesn't make sense to have a negative value with big decimal. And yes, you can do this kind of validation here as well. So you can use if negative or any kind of thing. The record is a fancy class where by default you convert these fields as multiple. But basically, everything that you can do with class, you can do with a record. For example, here, imagine a scenario that I want to sum money. So I have a value, and then I want to sum money. So what I can do, exactly something that I could do with my class. So sum, money, money. I'm able to do the validation here. So money is required. And then I can check the currency. So this currency equals money currency. I will able to summarize. Hey, yeah, you. So what can I do? I have my results. I come here. So this value, add money value. And then I'm able to define my context here, whatever I wish. And then return this value as a new money. So currency, result, and that is it. So right now, and throw exception, JDI lesson number 2, always put generic exceptions. So if without message as well. The idea here is just to validate, right? So what I did, I put the validation, I check, and right now I centralize the whole behavior of money in a single place. I don't need to duplicate code. And one-trick lessons. I don't even need to memorize the operation. I don't need to use utilitarian class. One thing that I usually say is everything that I need to remember, I will forget. Make sure that your API is able to be silver bullet on that case. So I have my player, I have my money. Let's create my team. My team will be my aggregator, right? Because this little guy here will have both. My team will have my player, of course, the name of the team, and usually what I do have is a coach. Let's create a class. So what I do have, I have coach, money, player, team, and when should I use repository? As you know, as when you wish to do any kind of integration with database. I can use the regular way that everybody usually do, right? With a suffix, so player repository, and then do any kind of integration that you will wish. And finally, I do have my service. Of course, you probably know the difference between anemic and rich model. The idea is to centralize a lot of behaviors in the players or even the entity. For example, if I wish to update my code or include a new person team, I should centralize everything here in the rich model, for example, here. So I will include a new player. Then do the validation. As far I know, I should have the maximum of 10 players, right? Something like that. Elias, you are Brazilian, you're supposed to know that. No? Is somebody familiar with soccer? No? So I should validate some numbers that I have no idea, so I guess it's 10 maximum. And then do the validation and then include this person. So I can centralize the behavior in a single place. But But sometimes I need to do integration. For example, imagine right now that I want to transfer players to another player. And then, of course, I don't want to, for example, put web service integrations, database integration directly in my model. So what can I do? I can use service. So I will create a service class to remove these complexity and injections directly in my model. And that is the idea number one. So when you talk about distributed systems, the first step is care of business. So we design the application, we design the domains, and eventually, more often than we wish, we need also to go to. There are a couple books, don't worry, I will share the GitHub repository later. But the point is, I need to merge because I have my modem, my API in Java, because we do love Java, and I need to store this information in any kind of database, like relational database, like NoSQL database, where we have several ways to handle with NoSQL, such as key value, document, wide column, and graph. And both are basically a merge, right? Because Java has polymorphism, Java has encapsulation, Java has several things that does not have support to the database itself. As the database has transactions, has relationship that Java does not support. And based on that, we learn a new word, the impedance mismatch between Java and my database. And that is the issue number one. So I got that to become a JDI, I need to understand the business first, the why, the reason. And then I need to face a new issue, is how to handle, because I have my domain, I have my goal, I have my database, and both are different. And right now, we're going to go to the step number 2. That is the isolation. That is one way to make sure that my business is safe from technology. And that sounds weird, right? Come on, Otavio. We are writing code using exploring technology. How do you dare to talk about this kind of thing? That's the reality. So if you go, for example, to just enough soft architecture, a risk-driven approach, I put this code here where the abstraction is one way to fight against the complexity. So instead of have a single blob or a single structure, I break down that in small pieces, right? I'm able to do that because otherwise I'm going to do the ball of mud, a structure monolith. And every time that I do that in a single place, it's hard to maintain. It's hard to write tests. It's hard to do a lot of things. So what are you going to do? Write more layers, right? So there we love MVC, model, view, controller. So 3 layers. But eventually, the layers become an enemy, like the hexagonal model. Who hates that as well? I do. It's a buzzword. But the point is, as much layers you're going to put, it's harder to maintain, it's harder to understand, it's harder to even write more features. And you go to the first step, that is business, isolation. And another point of isolation is performance. If you're able to isolate your business from the modeling, you are able to take advantage of your code. You are able to do advantage of the several NoSQL database or SQL database if without impact your business. Okay? So the idea right now is, okay, I explain you the business, the reason, and isolation performance. And the next question is, how can Jakarta help me to achieve these results, right? how can I use the Jakarta specification to achieve the 3 steps? Jakarta specifications, you can use three ones. The first one, I guess you are familiar, that is JPA. The second one is Jakarta NoSQL, and the third one is Jakarta Data, where we're going to talk about those two right now. So what I'm going to have here is I will use my single application, my Pawn application, where I have my app, as you can see here. To simplify, to make it easier to us, what I'm going to do is I will use a single Java SE application. And based on that, I will create my integration with MongoDB using the same business. So I will take, for example, here, my player. I will use my JDI Power number 1, that is copy-paste, and bring to my performance detail. And right now, I will use annotation to do integration between Java and NoSQL database, for example. On this case, if you are familiar with JPA, it's kind of easier to you because, okay, I want to define an entity. So you can use the entity annotation. Simple like that. I want to define my ID. You can use the ID annotation. And you want to define a column that will be that has persistence 1 by 1. Which annotation should I use? Column. So right now, everybody is able to use the specification, especially because it takes the same nomenclature that you are able to use as Java developer. So I have the same thing, player, username, city. I will remove the salary just for a while. I'm going to show to you why. And right now, what I'm going to do is I will create my constructor. So I have my constructor. I will have my default constructor that I will show to you why later. And finally, I will do my toString because this one here will be my front end. Why not? I will create my instance here. And I will create my player. The Neymar, the unique one that I know, and Pele, of course. So I will come here. I will have the Neymar player. Hopefully, I'm writing properly, correct. Neymar. And finally, the city where he was born, that is Santos. Right now, what I do have, I have my Neymar with the username, the name, and my entity is complete. My next step is, okay, I have my business, I have my goal, and I want to persist that on my database. Once I'm talking about NoSQL, I will use the most popular one, that is MongoDB. So to do this integration with NoSQL, Jakarta NoSQL provides a template interface. So once I'm talking about document integration, let's do it with document template. Document template. I will inject using my container. Oops, let's do a couple of the enters here. And what else I need to do? Let me check here. So I need to use configurations to define the properties to do the connection. Of course, I need to make sure that my database is on. So I will come here. I will take my container. I will start. my MongoDB instance. I will start. And based on that, what I'm going to do is create my application, Neymar application. Right now, I will do the insert. I will retrieve that information, so find by player, where you can use the ID, Neymar. That's probably I'm writing wrong. The API that I do have here it works with over Java 8, so we are able to return an object as an optional. The idea here is to, okay, I don't know if the information will return or not, so instead of check new pointers, you are able to use optional to do any kind of validations. And finally, what I'm going to do is I will delete. So templates, delete, player, class, and the ID. Oops. And as I said, I will use this result as now you, but Neymar. And then I will do it again, the empty result, where I will use my call-paste power here again. And then I will execute, and let's play to everything work, right? So the first step, as you can see, I insert any kind of operation in my NoSQL database, Neymar, that probably I write wrong. And then I delete, and then I return again, of course. There is no information there. A good point is, okay, right now, Otávio, you are doing a tight integration with a NoSQL database. And you mentioned about isolation, right? I don't want to be super tight with NoSQL database. I want to have an interface where I'm able to do this integration. One solution that we do have, that we do provide, is the repository interface. So you can define as a team, because if you remember the approach of the DDD says that we are able to do a collection of, and a collection of players is a team. On this case, I create my interface, then I will extend a pageable repository where I have my player and also my string. And to activate this integration, what can I do is make it happen. So I will come here, I will have my team, where I come here to my container, I will inject this little guy here, and instead of use the template, I will comment, and I will use my team right now. So I will use my team here to save, where for some reason, okay, I'm using the business here, but let's save here, and I will find by ID. So I will repeat this method by ID. So let's check what's going on here on my team. So not you. So let's return, and everything will be okay. And as well, I'm able to delete my team and do the exact operation that I could do. So I did a save, find by ID, delete. So delete by ID. And that is it. So I have the same idea of do operation with this NoSQL database. So right now, what did I do? Right now, I'm a little bit far from my NoSQL details. So I do have my repository. Of course, if you wish, you can use the classic, like rename player repository. To make it possible. And what I'm doing here is integration. As usual, you can do queries using in exploring the idea of method by query. For example, here, given that I wish to do a query by name, we are able to do the find by name. Find by name, where the name is here. So right now, instead of delete, I'm not delete anymore. So I will come here, I use my team, find by name. And right now, instead of do the search by ID, what can I do is use the name Neymar to make it happen, right? So Neymar's, and then I will return here. So the result Neymar's. So I need to don't delete to make it easier for me. But the idea is I can do integration with NoSQL if doubt my entity care about it. Because if I look into the API perspective, I do have no idea where the data comes from. I just know that I have a repository. And that, by the way, is the main idea or the main difference between a repository and a DAO, a data access object. Because with DAO, I know the database that I'm using. I know exactly the operation that I'm doing, right? Because usually when I handle with the data access object, I need to do the insert, I need to do the update. And right now, what I'm doing is I'm saving. And then my implementation will check if my information is there. If it's true, it will insert or update. Otherwise, it will insert. Oops. Right now, we have here. Another point is, imagine that I want to handle with components. For example, as I mentioned, I do have my, oops, you're not supposed to be here. I have my team repository here, I have my player. But imagine right now that all my entities, I have the option to find by name. Or, for example, what I do have, I have several common behaviors in the query. Of course, I don't want to multiplicate this information. I don't want to duplicate that information. What can I do? I can use it and explore components. For example, I can create an interface that I call basic query here, where I will define a type T and list of T find by name. So string name. And instead of I have my player repository with this feature, with this information. I come here, and right now I will include one more component. So my base query of player. So instead of duplicate the common queries behaviors, I'm able to create several components exploring interface. So right now, I will run again this app. And the idea is to keep the same behavior. Okay, as you can see here, I kept. So my player here, it is still Neymar. Of course, when we talk about real life, we also need to handle with pagination. We also need to handle with more details where we usually need to think how to do it. With this specification right now, if you're familiar with, for example, JPA, you need to do it manually, right? So we need to do one by one, query by query, probably check the Stack Overflow. Actually, doing question to ChatGPT, hey ChatGPT, how can I do pagination with JPA? The good news is you don't need to do it anymore. You are able to do pagination by default using, for example, this new specification that is Jakarta data. So a simple here, I'm extending the pageable repository. So let's take a look on this little guy here. And this one here, by default, returns me a pageable with page. So what I'm going to do right now, instead of return by name, let's put more players. At least I know a second one. Each password these days, right? Pele. Pele. And right now, I will save both. So I will save Neymar and Pele together. So list, Neymar, where are you? And finally, Pele. Save all right now. And then instead of doing query by file one for another one, I do a query find by everything. So I come here, I will delete, I have my team, I do find all, where I need to return a pageable. Each I can find the page. So my page number will be the page number 1, and then I will return the page. So right now, what can I do? I can do, I get the total elements, the total page, and things like that. And of course, the result. And you are able to do the for each, for example. And you are able to do the pageable or even the next pageable. So I come here, next pageable. And right now, I will increment the numbered page. So what I'm going to do here, I will come to my page. I will do the for it. And then I will execute again. So right now, I have my page number 1. Of course, I only have 2 elements to work with this pagination. I need to be a little bit more smart. So pageable of the size of 1. And the page number 1. And then I come here with my pageable. I will replace with this little guy here. Spaceball. So, and then do the query again. Team, find all with my next spaceball. Where this one here, will be my page number 2, and then I will copy paste my page number 2, and then execute again my second page. So let's see the page. Oh, of course, I need to identify better page 1 and page 2. To become easier to understand what's going on there. So, what did I do? I did a pagination. So, in the page number 1, I got the player Otávio and then Neymar, and I'm able to do jump one by one, step by step. Okay? You are able to define a sorter. You are able to define a way to order this information. The point is right now, you don't need to go to check the ChatGPT anymore. You're able to memorize step by step about what's going on. So to wrap up, the idea today is to, okay, how to become a Jedi of persistence, and to make it possible, 3 steps only. Business, understand the reason that we're doing. You're able to explore a lot of DDD to make it possible. So using value objects, entities, and so on. The second one is isolation. Make sure that your business are safe from your business of the technology that you are using. And the step number 3 is once you have the isolation, use that to take advantage of the database itself. And to help you with that, you are able to choose 3 specifications. The JPA, relational database, you can use JPA. To NoSQL, you can use Jakarta NoSQL. And one layer above, you can use Jakarta data to make far from the data perspectives. And to wrap up, I will show it later, don't worry. But the main idea here is the reason that we're doing. And the main reason is, of course, the simplicity. The idea to do and to write and to design code is to make it easier to somebody else to do it, to somebody else to achieve that. And that is it for today. So thank you and hope you enjoy it.
вас? Аз скоро не. Днеска и утре.
Ама в тази зала или в другата?
Не, аз съм си тук. В смисъл, аз нямам лекция.
Аз мислех, че имаш.
Готов? Да, аз мисля, че още минутка имам. Картинивки, Okay, so everybody had lunch? Everybody had enough food? Okay, now this talk is usually the hardest one because you don't have to sleep. But the topic is so nice that I think that it's going to be really awesome. So really, really great pleasure to introduce Anton. Just go ahead. The stage is yours. Thanks.
Thanks a lot for the introduction. I really I'm very glad for the opportunity to speak at the conference. It was a dream of mine for a long time to come here and talk. I hope you enjoy the presentation. And hopefully you learn something interesting from this. So my name is Anton Krosnev. I'm a Java developer with more than 15 years of experience. Currently I'm working at Experian. I have 3 kids. They're all boys actually. And in my free time I like to go to the mountains with my bike. But before I start the tech talk, I would really like to make my use case. So I'm gonna show you a project that uses TensorFlow as machine learning algorithm framework and Java, which is not very common combination. I hope you all had lunch because I'm going to talk a little bit about food right now. I really like apples and all the products that are made from apples. For instance, apple juice or apple pie or apple jam. And I was never wondering how these things are made until I saw a movie clip with my kids. So I want to share part of it with you, a tiny piece, and it's called Apple Fruit Factory Tour. And this guy here is called Blippi. He's one of the most famous YouTubers for small kids. This clip alone has more than 140 million views. And it shows what is happening in an apple factory, actually.
They get sorted by the ones that look really tasty to eat and ones that don't look tasty to eat.
So all these apples that get sorted, they go on a different conveyors, they go to different places, and different things are made from them. But how can we automate this thing and move from this room full of people to this sorting machine? The sorting machine uses ML computer vision to sort apples in different categories, and based on their qualities and good look, some are sent to the store, some are sent to make juice or apple pie or jam, whatever is suitable for this type of apple. So this apple machine sorts about 2.5 tons of apples per hour, which averaging 5 apples per kilogram is like 12,500 apples. And this roughly makes 3.5 apples per second. So we need to process 3.5 images of each apple per second. And this roughly makes 280 milliseconds per image in order to apples to reach in order classifications for given apple to reach the sorting machine on time. We really need to make this quick. And so to facilitate this, we need an ML model that will classify the apples in 5 or 6 categories and send this to the sorting machine. So how our system would look like. By the way, I've participated in a couple of projects similar to this one, so I have seen this in action, and yeah. So our system, given this oversimplified architecture, what would it look like? What it will actually look like? This is an industrial camera that takes pictures in a dim environment and takes pictures very quickly, and it's very robust. We need a piece of software that will send those pictures to the machine learning model. And when the machine learning model classifies the apples into our 5 or 6 categories that I mentioned about earlier, it's gonna send it to a piece of software that talks to the sorting machine. And we also need to capture the images and the classifications from the ML model and store them in some cloud storage, so we can later retrain our model and make it better, or for instance, for all the classifications, we can derive some statistics and, for instance, present them to business or wherever it's needed to use them for. So our ML framework of choice, because there are a lot of different ML frameworks on the market, but we choose TensorFlow, partly because my colleague, the data scientist, said this is the industry standard in the moment. And the other reason, it has a really cool feature that it can support training on distributed environment, which has a couple of machines with a couple of GPUs, and the data scientist can really experiment very quickly with different architectures of the ML model. The other cool thing about this is its open source framework, and it's created and supported by Google, but also it has a broad community around it. For instance, the GitHub repo of TensorFlow has more than, it's one of the 10 most popular repos in GitHub. So this is our final version of the architecture. So which component should run where? Because yeah, for the camera component, we need something that's really one USB cable away from the camera. And also is the case for the sorting machine. It really needs to be connected to a piece of software that's controlling it via some interface. But for TensorFlow, we have a lot of options. Run it in the cloud, and that's probably the most obvious choice. You can pick Google Cloud, ML, or Amazon SageMaker, or Azure Machine Learning. But unfortunately, to do that, you need a stable internet connection from your where you consume the ML classifications to the cloud. And most of the Apple factories are made in distant, remote locations where the connectivity is quite spotty. There are long outages, or it's very slow. So we decided to make this also on-premise, because then we can have a reliable connection between the ML model and the sorting machine. So we decided to put a couple of servers in the rack of the Apple factory. Yeah, this is typical Slavic data center with rack on the on the desk. So how do we communicate between the components? Because these 4 components need to communicate with each other. And the obvious, maybe these days the obvious choice is REST, because REST is the best, and it has a lot of libraries and examples for REST, and you can easily do something with it. But I have worked on a project that used REST for this type of layout, and it wasn't the best option, so to say. The reason we used it is because the infrastructure didn't support anything else but REST, and it had some downsides. For instance, it's not very easy to make sure that the camera sends images to the ML and to the cloud component. And either you have to pipe everything from one to service to another and then do some forks, and also when the connection is down to the cloud, you need to code some storage on disk that will the images should be stored there until the connection is back online, and we can retry to upload them in the cloud. In the second project that we made, it was possible to use whatever we want, so we picked Kafka, and it has some quite few positives. For instance, it's very easy to send to multiple consumer groups a single message, and you don't really have to worry, did that consumer receive that message, or did that consumer missed it and needs to retry? It's all Kafka's job. It's also asynchronous by nature, and it has some really cool APIs that I'm going to talk in a minute about them, that really match very well our use cases here. The only downside, we thought it requires really fast storage in order to work properly. And scaling Kafka cluster is a little bit tedious operation because you need to update the configuration for each other service and specify that there is new Kafka instance. So this is our final version with the 4 components and Kafka in the middle to communicate with. Also, there are 2 Kafka topics. One is for the images, and the other topic is for the ML classifications. So camera will send images, and TensorFlow will read image and produce classification, and then the classification will go to the cloud component and to sorting machine, but also the cloud component will pull images from the image topic and also upload them to the cloud. So what language should we choose for these services? The obvious choice, no, there is no obvious choice, but for instance, Python is the main language for TensorFlow. And as you know, Java is for Kafka. So of course, they both have, Python has, Kafka has Python API, and TensorFlow has Java API. Of course, one can write everything in Python. Sorry, I shouldn't say that in Java conference. But if you do that, you miss something really cool. And this is the Kafka APIs that comes with the Java client. For instance, our image and ML classification uploading component can leverage Kafka connector and use this Kafka connector API and sync. You can get a so-called sync that will upload the images and the classifications to the cloud. They are ready available for major cloud providers. You can just pick it off the shelf and configure it. You don't need to write any code for this. And for the camera, well, the three brands of industrial cameras that I worked with, they all provide C++ API for Linux, which has a Python wrapper on top. And it's really easy to build a service that will capture images and send them somewhere. And having the Kafka Python client, it's a piece of cake. The other thing about Python is that it has a nice variety of image manipulation libraries that run really quickly because they're usually backed up by native components underneath. So for TensorFlow, it's not very obvious. The default API is Python. And in TensorFlow 0.1, Python API looked like this, and Java API looked like something that you built in your garage from scrap. You almost cannot do anything with it. And the Python API was actually, that was the main API. You can build ML model with it and train it and do whatever you want. I mean, it's very, very powerful. Fortunately, in TensorFlow 0.2, the API was split in two parts. And on top of this small Java API that used to be present, there is a new high-level API that has all the components that Python has. It resembles closely Keras, and you can do anything with it. You can train the model, build new neural network, or everything that's possible with Python. So we decided to pick Java API, not because we're gonna leverage those features, but in order to use Kafka streams, because this really makes it easy to to consume data from one topic and publish it to the other topic. And it does all the heavy lifting for us. It's committing offsets and retry and doing retries, and it's very convenient to use it. So after we run the cloud component, and we are able to capture like a couple of thousand images per each category, we can we can start our colleague, the data scientist guy, will train our model. And then we can build our TensorFlow model that uses the ready-made ML model to classify images. So, but first we need to figure out how to pre-process the image. This is a step that we usually do to feed the ML model with the image. So for each pixel of the image, we need to take the red, green, and blue values of the pixel, and because these are our single byte between 0 and 255, we need to convert this in a floating point that's between 0 and 1. And then when all this is done, we build the so-called tensor. That's a huge matrix of all these numbers. And we feed it to the neural network, to the input layer, actually, of the neural network. And when the classification starts, these numbers will flow through different hidden layers of the neural network. And then on the output layer, we will find something, all the different classifications that we had. And for each classification, we will have a number representing how certain the ML model is that this image belongs to that class. And I want to show a small demo. I'm going to use Inception V3 ML model that's created and trained by Google because I couldn't find Apple dataset on freely available, so I couldn't train my own ML model. And let me switch to see if it's running. Okay, so let me zoom that for you. This is my consumer that will actually resemble the sorting machine consumer. So the payload that it's receiving is image label. That's the classification actually. This one is for pufferfish. And the probability that the ML model has found for this label. And we also receive the time that has elapsed for the image classification. In the Kafka headers, we have the timestamp when the image was produced, generated, or if it's camera when it's taken. And we have the producer ID that's actually, which is that camera, if we work with multiple cameras, for instance, and multiple sorting machines. So having that said, let me show you the code. So this is our Kafka stream that is really one small class. It's a it's a Spring Boot service, and it's one small method. And the K stream actually is consuming from the one topic, and then we transfer the image to JSON, and that is then published to the producer topic, the classification topic. And yeah, that's pretty neat. And what happens in the TensorFlow part is a little bit more complex. Not it's that complex, but it's more code. So we first read the graph from the disk and load it as bytes. And with this, we construct the TensorFlow graph, which actually represents the ML model. And then when we construct the graph, it's this done on the initialization step. Then we can classify our image. But first, we need to build the so-called tensor, the huge matrix. And for this thing, we have this pre-processing step that actually is doing this stuff. It first decodes the JPEG compression of the image, so we get the raw pixels. And then we make batch of one, because we only want to classify one image at a time. And then we have the size, which is the input size of the neural network, the input layer. And mean and scalar to convert these values to between 0 and 1. And once this is done, we feed that tensor to the session that is constructed from our graph, and we give it to the input layer of the ML model, and then we fetch the output layer. And this code below extracts actually the labels that the label that has highest probability, and that's what it's returned by this classification. So let's see how this thing performs on my laptop. I have a simple plot that my friend, the data scientist, gave me. So yeah, it parses the logs and draws these graphics. So currently, our performance isn't that great because we were opting like 280 milliseconds, but most of the classifications and the whole time it took, so it's a little bit more. And yeah, let's see if we can somehow, if we can do something about it. When I started doing the code for the demo, my Python was a little bit rusty, so I decided to ask ChatGPT to create a Python producer for me, and this is literally what happened. I had to debug a couple of errors, and it took much longer than if I did it myself with all the reading and browsing Stack Overflow. So can we optimize this further? And I mean not optimize it like throw more hardware at it and make the throughput, make a better throughput with more messages, but how we can optimize the latency that we receive the classification at our sorting machine consumer. So any ideas about this? Sorry? I didn't understand you. Okay, so when you start TensorFlow, sorry, I couldn't understand you. If you can come here and say it a little bit clearer. So for currently, TensorFlow is running on my CPU. So when it starts, it prints a message like that. And what this actually says, it's the binary is not compiled to use these instructions that are available on my CPU. And there is good reason for that, because it's compiled to run on older CPUs. So if you have older laptop, you can still start it and run it. And with AVX2, there might be some boost. So we found that benchmark that was deleted from the official documentation, but was still available somewhere in GitHub. And it says that AVX2 will give some boost. I mean, 7 images per second, and yeah, this 42 milliseconds per image. Yeah, so we decided to give it a try. And to do that, we need to recompile the TensorFlow binary, which turned out to be not that easy task, because the TensorFlow binary is built with Bazel, like most of the Google components that are on GitHub. And nobody in the team knew anything about Bazel, so we had to read and dig and read a lot of scripts and documentation, but eventually we figured out how to do it. And we managed to build it, but then was another struggle how to produce Maven Maven artifact that we can use in our Java code easily. But we managed to do that as well, so at the end it was ready, and we deployed it on the first server, and it was running great. And on the second server, this is what happened. It went to crash loop with this error message, complaining that the CPU that is running on doesn't have the AVX2 instruction set. It turned out that the second server is a little bit older. And we went back to using the CPU-only version. But then, since the performance wasn't great, we managed to secure additional funding for hardware, knowing that TensorFlow can run on all these components. Yeah, the first thing is here on the top left is CPU, and bottom left is Raspberry Pi. And this on right down here, this is called a TPU. But unfortunately, it's only available in Google data centers. They claim this is the fastest thing to run TensorFlow on. And what we really make sense to get was the GPU, the old graphics card that you have on your gaming laptop. So we tried to, we wanted to build and run TensorFlow on it. And luckily for me, my oldest son gave me his gaming laptop for this presentation, so I have a GPU on the machine. And let's try to modify our binary. I have pre-built that. I have two Docker images, one with CPU and one with GPU, because building it takes some time and I don't have it. So I'm not going to show you how to run Gradle and make new Docker images, but we'll just swap this and restart. And then I'll explain what's needed to build the binary. Yeah, sorry. I did Java comment, sorry. I'm a bit nervous. Now it should be okay. Thanks for shouting out. Okay, so now it's restarted. I'll give you a couple of seconds to initialize, and I'm going to show what's needed to be changed here. So the first step is to replace TensorFlow implementation, not the Java API that's first thing here, but the native library implementation. So we change this discriminator to use the GPU at the end, and actually uses a whole different binary for the TensorFlow native part. And once you build your new Spring Boot jar, you have to come and rebuild your Docker image. And to do that, you really need to use NVIDIA CUDA as base image. CUDA is floating point mathematical computation library that is developed by NVIDIA, and it uses mostly the video card and the GPU itself. And once you have built your Docker image, you need to also have the GPU driver installed on the host server that runs the Docker container. And you also need to install this Docker runtime container, NVIDIA container runtime, which is Docker extension that allows Docker to use the NVIDIA driver. And then you have to instruct the Docker engine to make the GPU available inside your container. So once all this is done, and just to mention that you cannot use any version of the CUDA, but it has to strictly match the version of the TensorFlow binary, because otherwise it says it cannot find some native libraries or their version mismatch, and it will fall back to CPU. So let's see if my image is running. It's running, yeah. Good sign. It's CUDA is present. So and then you see some complaints about something missing in my kernel, in my Linux kernel. And hopefully at the end you will see something like this, that the GPU device is created, and it has that amount of memory, and it's make and model. Usually it's only possible to run it with. I don't know if IT cards are supported now. It was a little bit tricky to run it on the ATI GPU. But yeah, it's running right now on my NVIDIA Out GPU. And let's see if the performance has somehow changed. Yep, this is the previous run, and then we have this spike because it needed some messages were delayed while the container was restarting, and this is the new output that it's really quite lower the latency right now running on the GPU. So having that said, I really want to speak about a little problems that we come to solve running the whole thing for a while. And for instance, the configuration of the Kafka topics. For the image topic, this is quite unusual configuration. Usually people, when they run Kafka, they want to have exactly once, don't miss any messages and stuff like that. But we are kind of okay if some images, for instance, couldn't be uploaded to the cloud. We're still fine. There will be a lot of new images to come, and we'll have enough for model retraining. So we want to keep the size of a topic somewhat limited in order not to fill our Kafka storage and have to clean up manually the Kafka servers. Also, the replication factor is 1 because we decided it's okay if the Kafka node crashes, we'll lose a couple of images, but generally we lose a couple of images to be sent to the sorting machine. The classification will be missed, but in general, this can happen. And using replication factor of 1 will really will not replicate across the Kafka cluster, and will give us a little bit of performance boost. And the other thing about the decision topic is that we want to keep the messages there for a really long time. In order, if we have some issues with the internet, it will still, hopefully it will be back in 2 days, and then we can upload the small messages into the cloud and not miss any. So our statistics will be relevant and we don't miss something. And we also wanted to keep the replication factor for all the Kafka clusters, all the nodes in the Kafka cluster, so that if a Kafka node crashes, we still can deliver what it has been processed to the sorting machine. Another thing we learned the hard way was the memory usage or memory configuration. When you run TensorFlow, especially with the CPU part, it stores your ML model. When it's loaded, it's loaded outside the JVM in the native memory. So if you limit your Docker container, for instance, if you run it in Kubernetes, and you have some limits for the memory of the Docker container, you have to give it enough space for the JVM and for the TensorFlow part where the ML model is loaded. If you don't do that, you know what will happen. Your Docker container will get killed, and yeah. So that's pretty much all from my side. If you have any questions, I'll gladly take them. And this is the GitHub repository with the example that I just showed. Sorry? Yeah, that's a very good question. So in my example, the pre-processing happens also in the TensorFlow part where you saw that graph. Let me go back to the code. And yeah, that happens on the pre-processing part is also running on the GPU when we switch the processing components. For instance, when we first built that thing, our pre-processing, we did it as pure Java developer. So how do you pre-process that image? With AWT, of course, because it's built in the JVM and it's easy to use. And some guys know it. So, but the problem with AWT was that it's not optimized to any CPU or let it talk about GPU, of course. And it was actually taking longer. The pre-processing step was taking longer than the ML model classification itself. And it was very inefficient. So that's why we came up with this more obfuscated code that uses TensorFlow to do that.
Yes. Do you send the tensors directly, or do you send the JPEG images which you receive?
We built the tensor here in this part. So the JPEG is decoded, and then we built a separate tensor, and then this tensor is set to the ML model. You can put that part in your ML model, build it in your architecture of the graph there, but usually we didn't do that because we wanted to keep them separate, and really that way you fix. It's a bit harder to comprehend.
No, I meant rather. You store the images somewhere, so you can later retrain the model so it can become better. And do you store the raw images, which are the JPEGs, the undecoded JPEG, or do you store the tensors?
No, we store the JPEGs because they use a lot of less space and travel faster through the network.
So the JPEGs use less space than the tensors?
Yeah, the JPEG is compressed image and it's very small. Like, for instance, these images here I'm using are like 300 kilobytes JPEG. And if you expand that and JPEG it, it becomes 4 megabytes or something like that.
I see. And also, when you used that, what was it, Inception V3 by Google's, this was a model which can classify all types of objects, right? So
like 1,000, it has 1,000 different objects can be classified.
But for the Apple example in particular, something much smaller can be used, right? Because you only need...
because it's only apples and it's only one thing in fairly... The scene is fairly concrete. You have a bit of conveyor and the apple is in the center, and it's always like this. It's fairly easy to generalize the ML model on this type of images.
Also, on this particular problem, do you... this was a real example, right? I'm not digging too deep, right?
Yeah, so?
Okay, so I was thinking, how do you know that, because you only have one image of one side of the apple, do you actually process a couple of images of the apple on each side? And this will take additional time for the classification, or only just one side and hope for the best?
Yeah, usually to make it really useful, you probably need to take 2 images from 2 sides.
Yeah,
or for instance, you can use some depth image of the camera to see if there are bumps on the apples or something like that.
And lastly, for the model, in the example, you said that it was an input layer which you feed for each neuron. It was the values of the pixels, so RGB, and you normalize it so it's 0 to 1, right?
Yeah.
And is this inception V3 by Google on this principle, or is it a convolutional network, or?
Yeah, it's convolutional network, but yeah, it's the way the model is built. It's actually expects values for each pixel to be between 0 and 1. There are some, I saw different types of neural networks that expect integers, for instance, to arrive there.
All right, thank you.
Okay, so any more questions? If there are no more questions, I'll stop my presentation. Thank you all for coming.
It's very, very complicated, but you did great. Thank you so much. So 15 minutes break, and our great friend Heinz Kabutz will be presenting here. See you. Yes.
Right? And you ask somebody random from the audience, you were like, who has like Groove installed? Who has Scala installed? Who has something else? Right? And then you took a random laptop from the audience member.
It was in Ukraine.
Yes, it might have been in Ukraine. Yes,
Con.
yeah, GE Con. Exactly. And you took a random laptop from a random audience member, and you just did whatever with the presentation you wanted to show on a like random unprepared laptop with just the terminal and the languages.
Credit goes to the guy with the laptop. He was amazing.
Yes, he was standing behind your shoulder, watching as a hawk.
He was.
That you are not going to steal his credit.
This is a random person, random computer. This is a talk on 5 languages. And I'm like, you got Scala? It's like, no, you got 10 seconds to install Scala. As I walk to your computer. And the guy is like, Brew installed Scala. And I'm like, let's do it. Everything from the shell, the REPL. Because I don't know his machine. I cannot use tools. So we did the entire talk in the REPL.
That was amazing.
Everybody thought it was staged, but it was completely...
No, it was. Nobody thought it was staged.
Oh, there were people who thought that we were just making this up.
No. Nobody thought it was staged. It was just the pure mastery, right? And then,
yes, absolutely. No, it's I only heard of it. He could see it.
Yeah, that was amazing. And then I figured out, like, I'll be fine with my sessions being like average, like all the time. Like, it's just there's no point in trying.
Absolutely. I like it. So.
That guy was amazing.
Yeah.
And he had to do the same thing the next day as well. Because the computer just failed. It wouldn't recover the entire trip.
I really wonder how can a computer fail nowadays, but it can.
No, but that was also years. That was years ago.
Yeah.
That was years ago.
Anyway, so it's so nice. It's 2 a.m. for you.
No, actually, it's 2 p.m.
Yeah. It's 2 p.m.
Yeah.
Okay.
2 or 3. Yeah.
Because I'm still used to...
Local time.
No, I mean, I used to that we have 24.
Yeah. We are still in barbaric units.
Oh, well,
we still
it's...
use Fahrenheit.
but
we still use 12 hours.
no, but anytime I say in English it's 14 hours, they say, what was it? Oh, 2 p.m. That's good.
Yeah.
Nice. Did you get the stamps? All of them?
What do I get when I get the stamps?
You get a beer, but I think you have a beer cup.
I don't drink beer, so it's fine.
I have presents, but usually people like it.
I'm at this stage in life where I don't stand in line to get stamps, to get the T-shirt.
Yes, you are old.
Yes, I'm officially old. I can buy myself a T-shirt. Right?
You're post-T-shirt, post-stamp.
Like, look, this is amazing. So I went to the VMware stand, and they had cards, and they had this thing, and they gave me a hammock. What?
Hammock.
Yeah. So, like, this is amazing. Like, I think it's an actual, like the proper size hammock.
Okay.
And I will. Yeah, it's like a VMware like thing. You can just get it out. No, like so. And then random questions like.
1 minute.
And you just tell them, this is this, and they're like, how many hours does it
Okay. So please take your seats. So we're about to begin. I'm really happy that a very good friend, amazing friend of our community, Heinz, is back to Sofia to give a presentation about productivity with IntelliJ in front of a guy who actually writes IntelliJ. Yes, so he will control him. And yes, we're really happy that you are back. And please, the stage is yours.
Yeah, thank you. I'm extremely happy to be back in Bulgaria, so thanks for inviting me. I didn't really, I think this is only my first or second talk I accepted in person since 2019. So when I heard Bulgaria, I said, I'm coming for sure. There's no question. Definitely I'm coming, Bulgaria for sure. Well, we're neighbors, and Greece is so close. All right. So I started coding in Java in 1997. At the time, there was we had this strange tool called JBuilder, and it sort of worked okay, but it was a bit weird. And then I went to Germany in 2002, and I was there for about a couple of months, and they used Eclipse. So I was blown away by Eclipse, because you could simply save it, and boom, it was compiled. And in comparison to JBuilder, it was an absolute eye-opener. And then I went back to South Africa, and I used Eclipse for about a year, but people kept on mentioning idea, IntelliJ idea, and I was like, okay, whatever. I'm happy with Eclipse. It's great. It works well. And but then I needed to work with some really terrible, messy Java code. It was very badly written, not well-factored at all, a lot of duplicate code, lots of code that wasn't actually used. You know the type of project written by one guy. If it's written by one person, it's normally going to be quite messy. And I also needed to work with Swing GUIs at the same time. And I'd heard so much about IntelliJ, I decided to try it out. So I downloaded IntelliJ IDEA. And in those days, there was no free version. So you had to, try it out for 30 days. And then after the 30 days were up, I actually paid the money to buy my very first, and last license. After, when the next version came out, I begged them for a new license. Please give me another license. And they kept on giving it. But I used it for 30 days, and I bought it. And I always say that I actually paid twice for IntelliJ. The first time I paid for the license, and the second time I was being paid per hour, and it made me faster. So I was actually getting paid less for the same amount of end code as before I used Eclipse. So, maybe I should go back to VI or Emacs, and then I can actually earn more money for the same amount of work. But anyway, I had a more pleasant life, less frustration, and it's really great. I'm not paid by IntelliJ. I'm not sponsored or anything like that. So this is just my own use, my own view. So the one thing that I realized recently is that they've added something called a toolbox, which is incredibly useful, because what it does is, you should download this. If you haven't downloaded this, download it. What it does is it keeps all the JetBrains products up to date. This is always a pain in the... We had to download the latest version and install it, whereas now it does it all for you. What's also nice is sometimes when the new versions come out, they have bugs, and they don't work properly. So with this, you can keep lots of versions installed at the same time. And you can roll back to the previous version. It's happened to me in the past where I would do a talk and I'd open up IntelliJ and then it just wouldn't work. Whereas now I can just go, okay, take the previous version, and it's really very convenient. So if you don't have this, get this. And then the other thing is that the default scheme that people use mostly is the Darkula scheme. That's the most popular still. But the way that they do the highlighting of errors doesn't make them stand out as clearly as if you've got the white background and you've got sort of a very bright red on a white background. They have sort of a reddish, but not very clear that it's an error. So I always try and update that and make it a bit more obvious that there's an error. The other thing that I noticed, and we spoke about this with early on, is that the key map for Mac OS X used to be very similar to the Windows key map. It used to be almost exactly the same. So you could easily go between Windows and Mac and Linux and Mac, and without too many difficulties. Because what happens is we sort of get to memorize these key maps, and it's really hard if you use a colleague's computer and they use a different operating system. But there's IntelliJ IDEA Classic, which is pretty much very, very similar to Windows, and it actually has more finger-friendly shortcuts than the official Mac OS X key map. What I did is I took the IDEA Classic and I adapted it a bit. I added a few more shortcuts for myself to make it easier to use. I'll talk about some of them now. Other thing which I find quite useful is if you want to select words, if you just double-click on them, by default it selects the whole word. If you use camel humps, case mixed words. If you say select use camel hub words, it only selects the part that you're clicking on, double-clicking on. So this is a nice, I always put that on. The other thing which I put on by default, and I'll show you this in a moment, is by default, they don't have this on. They don't have open files with single click on, and they don't have always select open file. And in my opinion, this should be on by default. So let me show you what I mean. So here, for example, first of all, the camel hump, I've turned it on already. So if I double click, it's only selecting the part I'm on. By default, it'll be the whole word. Right? It's easy enough to select the whole word. You double click and you drag it over, and then it selects the words. But what I mean is this. If I, for example, click on Elegant Frame, it doesn't open Elegant Frame. GUI tools, it doesn't open GUI tools. I've got to double click. And who's got time for double clicks, right? I mean, come on, this is 2023. So, and similarly, if I go to data input frame and I click on that, it doesn't select it on the left-hand side in the project. So what I always do is I turn it on. So I have open files with single click and always select open file. Now, this might have made sense in the year 2000 when machines were a lot slower to not open it immediately, but nowadays I don't think there's any reason except to keep it the same as it always has been. So now I can sort of move around, and as soon as I stop somewhere, it opens a file. So this is a lot more convenient, and I don't make that mistake of clicking on something and then not seeing the same file in the project view on the left-hand side. So this, I think, is an improvement over the default setting. All right, the philosophy of IDEA is, IntelliJ, is to be used mostly without a mouse. The one thing you can't do without a mouse is what I've just done, right? But that's almost the only thing you can't do without a mouse, is you can't go to the gear and select the scrolling. But besides that, like the general use, you can do almost everything without the mouse. And the idea is that you'd want to prevent moving your hands off the keyboard, because then you're going to have trouble finding the right place again. That's the theory, okay? That's as far as I know, the philosophy. And so they've got hotkeys for almost everything, and they've got a very nice shortcut PDF, and I recommend that you try and memorize one new shortcut a day. Some of these shortcuts overlap. So for example, you don't need to learn find action, because you can just do find anything, and you'll find the action as well. But there are lots of shortcuts. It'll take you about 6 months to go through all of them, but it'll make you a lot more effective and quick when working with IntelliJ, and a lot more comfortable as well. And you can track your progress with that. If you go to Help and My Productivity, it will show you how you're doing. So for example, here, I've used the syntax-aware selection like 167,000 times. Is that possible? Yeah, it is possible. It's, it's lots and lots of times from 2014 until when I made this slide, which I think was 2021. So, you know, in like 17 years or 7 years, I use it a lot. I'll show you that in a moment. But what's useful about that My Productivity is not what you have done, but what you haven't done. So if you click on that and you say, what have I not used, you might discover things that can be useful, which you could be using. All right. A very useful thing is if you want to look for things, search everywhere, just Shift will do that. And if you do 4 times Shift, it also includes non-project items. So for example, by default, it's only going to show your own classes. With 4 shifts, you're going to see also, for example, classes inside the JDK or other libraries. And I don't even know about this. I don't know when they added that. Might have always been there. But I kept on hitting this by mistake when I did the up arrow on my older MacBook Pro. And this window kept on popping up. I never looked. I was like, close this stupid thing. Until eventually somebody pointed out, actually, this is quite useful. You know, get to know this thing. So nowadays, whenever I look for something, Shift, and there's the dialog for searching. All right. I have to mention what happens when IntelliJ doesn't work, right? So, because I told you I'm not sponsored by IntelliJ, so I can talk about the bad things as well. And this was a while ago, all right? I was doing some coding, threading, and I started a bunch of threads, and my machine crashed. In fact, I had to like hold down the power button for it to shut down because it wouldn't respond to anything anymore. And when I restarted, and I tried to run a program. You can see by the looks of this Mac OS X that it's quite old. The following happened. I said start, and it said, okay, I'm parsing, compiling, loading files. And then it said, let's start, and then it goes, okay, let's start that again. So it kept on going round and round, trying to compile, not actually making any progress. And I decided I'm going to stop, so I clicked on stop, and it said, sorry, you can't stop it because the compiler's busy running. So, but the second time when I did it, it actually managed to allow me to stop it. So I thought, let me screencast that, make a recording of that for you. But what happened is that because I shut it down in an unorderly fashion, there were some corrupted files, which can happen, right? So the way to fix that, it's actually built into the IDE. It says you go to File and Repair IDE, and you basically step through until everything works. You don't have to go all the way. Normally, I don't want to lose the local history. The local history is really useful. So try not to lose that, but I typically will invalidate the caches as well, which will take a bit of time to reindex, but then at least you solve most of the problems. I've discovered another problem recently because I've got projects going back to 2000 and, I don't know, a long time ago. In that if I open old projects with a new version of IntelliJ, I get an infinite loop and it doesn't respond at all. I have to actually kill -9 on IntelliJ. Others have also seen this. And the way that I get around it is to create a new project with existing sources that overwrite the old project files, and then it works. So if you see that, just make a new project with existing files. Don't use the old project files, and then it should be working again, just in case it happens to you. All right. Now, there's a super key that fixes almost anything inside your code, right? And that's Alt-Enter. That's like the go-to key for everything. That's like the AI of the past, right? And it shows you intention, actions, and quick fixes. And what I like about it is it normally shows you a good option. There are other IDEs which show you like the worst option first, whereas this one actually shows you, usually, not always, but usually shows you the best option first. So Alt-Enter, and then you can just go and use it. Another one which is very similar is Alt-Insert on Windows, or I've mapped it to Control-N. So the one is Alt-Enter, and the other one is Control-Enter. So Alt-Enter and Control-Enter, or Control-N. So let's just make a little class just to show you how that works. So over here is let's make a playground over here. So make a person class, and we're going to put in here private final string first name, and we're going to do a last name as well, and an age. And age, can never change age. It's a final age. Now, if I press Control-Enter, it gives me a bunch of code that it can generate. Of course, you don't need any of this because you can just take a record, right? But if you didn't have records, you can now have constructors or getters or toString and so on. So I can make a constructor that lets me select all the fields, and I've got the constructor. That's one path to do it, Control-Enter. And then you can have the getters, the toString method, and all of that added as well. So your getters can be here, et cetera, et cetera. The other way is with Alt-Enter. Alt-Enter then fixes anything. So it's like your go-to for fixing anything that might be wrong. It's a bit like Control-1 on Eclipse. And here I'm just saying add constructor parameters. I'm selecting them, enter, and now we are good to go. All right? So there are two ways of getting to the same place. I don't think I'm finished yet, right? So two ways to get to the same thing, right? And obviously you'll change between the two. Oh, by the way, I've got this little gift for those who are here, data structures course in Java. It expires at 3:20, but I might extend it a bit because I don't, if your network doesn't work. But grab that tinyurl.com/JPrime23, or that link takes you there as well. And you have to get it before then. Once you've got it, you got it for life, so it doesn't expire. The course doesn't expire; just the coupon expires in an hour from now. So tinyurl.com/jprime23 gets you that. All right. So the other thing which is really, really useful is you can generate code with live templates. So if you just type PSVM or main tab, it generates your main method for you. You've got sout v, which I use a lot, sout m for the method name, sout p for the parameter, show what all the parameters are. And then you've got different forms of iteration depending on what you want to iterate over. So I'm going to show you a little demo of that quickly. So here we've got your, let's make a live template demo. So I want to add a main method, public static void main, or main tab, and you've got your method there. You want to iterate over the strings, so you go iter tab, you've got your iteration going. You've got a list of string, list equals string.off, not string of, list of JPrime, all the best conferences. Is there anything else? I don't think there's anything else. We'll keep it at that. List of, and you can iterate over that as well with just iter. Or you can do it AR for iterating over an array with indexes, or itco. So all of these shortcuts for iterating over things. So it's really very convenient for generating sort of the code we need to do over and over again. And then if you're inside a method, let's do public void foo, which has string bar inside here. If I do sout m, it shows you the name of the class and the method name. And sout p does the parameters. In this case, there's only one, so it just shows you the one parameter. And I think if you do it over here, okay, it doesn't automatically do it. It sometimes does it. Sometimes it'll convert it to actually an array over there, to arrays.toString. And then, of course, sout v will do a value, so printing out a value. The sout p is actually the same as sout p in this case, but it doesn't have to be. All right. So these are all the little tricks. And you can write your own. And the writing your own is actually where it gets really interesting. I'll show you that in a moment. The other thing is navigating. The way that I work normally, I know you're not supposed to use the mouse, but I like the mouse. You're not going to pry the mouse from my hands. So I really like my mouse. I mean, I don't like mice. My son sent me a picture this morning of our electricity board outside, and it's got rats inside at the moment. There's one rat who has decided to check out of life, but he's inside there at the moment. We need to get rid of him. But I do like the computer mouse, not other mice. So what I do is I sort of hold the command button down, and then just click on the button. So when you hold command down, everything becomes a hyperlink, each item in there. So this is very, very useful to navigate. You can also do Command B, which also goes to the right place, so Control B with Windows. And then I can navigate backwards and forwards with Control, Alt, left and right. So I'll sort of click onto something. So Command, there's string, let's click on that. Command serialize, we'll click on that. And so you can sort of click around as you want. And then once you're done, you just go back a bit. It's a bit like a web page if you're trying to figure out what's going on. So that I find very useful. And as I said, I like my mouse. I don't want to throw it away. And of course, it is useful to be able to touch type. And what I normally do is I've got my left hand on the keyboard and my right hand on the mouse. And it's easy enough to find the right keys because you've got these little dimples on little things you can feel on the F and the J. So you can find your way around without looking. It's not that difficult if you practice it a bit. So here's my hand. Now it's in the right place. It's the wrong place, right place. I mean, you can find it once you've sort of practiced it a bit. So I don't find using a mouse so problematic. I find it's actually quite comfortable to do that. And I find scrolling with a mouse more smooth than trying to use a keyboard. So that's why I'm saying that even though the philosophy is throw away the mouse, that's not my philosophy. I don't think it's necessary. I think the mouse is quite cool. All right, other thing which is quite useful are bookmarks. Right? You can actually set bookmarks across your project. So quite often you're working on something, and it's not very well factored code. So you've got, or rather it's tightly coupled. You've got 5 different places you need to work on at the same time. So you go to each one, and you set a bookmark. You say Control, Shift, a number, 0 through 9. And then you can find these numbers very quickly again by simply saying Control and that number. So this is incredibly useful. And I've got a few coding demos I wanted to show you. And I was going to set up these bookmarks beforehand, but I forgot. So I can't show you, but I might demonstrate them later on. The other thing that we have, which I use a lot, is my most used one, is the syntax-aware selection. This is Control W, and the official one is Option up arrow. Now, Option up arrow doesn't work for me because it's got 2 different, you need 2 hands for that. I can't like hold that and my hand's big, but not that big. It's like a giant's hand to have the, or use my right hand, which I also don't want to do. So I want my left hand on the keyboard and the right hand on the mouse, and extending selection won't work with the standard setting. So I changed it back to the official one, which is Command W, which works well, except when I use other applications. Command W closes the application if you're on Mac. So that's kind of a pain as well. But yeah, so that's what I do. And so expand selection and string selection are incredibly useful. So for example, here I want to select this code. Command W selects the word I'm on. Command W again selects the whole word. W, the string. And as I click it, it expands the selection more and more. And then if I want to make it less, I just do the opposite, Command Shift W, and I'm shrinking the selection down again. So this is really very, very useful. And as you saw, I use it a lot. And that also shows why I've got such a high number, because unfortunately, you do need to press it quite often to get the effect you want. You can also do something like this, double-click on the curly brace, and it selects that code block. Right? So obviously, I use this a lot, and it's incredibly useful. Also, if you need to move code around, up and down, Control-Shift up and down, or Command-Shift up and down will move it around. And IntelliJ is quite good with that. It basically tries to make sure that the code still stays legal. So you can't, for example, take try, just the line try, and move it around. I mean, it's got to be something which will still be legal afterwards. So it's quite good with that. All right. Now, I mentioned live templates and that you can write your own live templates as well. And this is incredibly useful. I'll show you that in a second. But also, you have standard live templates, which you can fire up with Control-Alt-J, Command-Alt-J. And again, it's syntax aware. So if you're in Java, it's going to give you options of callable, read locks, write locks. And for example, what I did is I changed main string array to main string ... I don't know if you noticed that. I've got my reasons why that's more useful. But here's an example. So what I did was, I often do coding demos, and there's one thing people keep on asking is, what is faster? Is linked list faster or an array list faster? Of course, to do it properly, you need a proper JMH test, and but in many examples, you can just show a demo which will take you like 2 minutes, and it ends the argument. Because if it's a difference between, for example, I don't know, 1 second and 1 minute, you don't need to do JMH, right? It's so obvious that the other one is slower. There's not much you need to do. So for doing just a quick demo, I want something like this, where I basically specify text like this, long $time equals system nanotime. I then put in the selection inside, and finally, I work out the end time and I print out what the time is. So if I, for example, if I'm inside here and I want to see how long does it take to do this loop, I can just do Control-Alt-J, press the N, and I've got my timing around there. So it really saves time doing that. Obviously, it's context aware, so you need to make sure you specify it for a Java snippet of code. And you can do this. You can actually write fairly complex scripts for this. I think it's using Groovy or something like that for the code. If you want to know how to do it, just look at other shortcuts, and you'll be able to, like SART-P, for example, show how to extract parameters. and then you can do it quite nicely with it. But this is really useful to be able to produce code very quickly in almost no time, especially doing demos and things like that. Something else which people tend to like is column selection. Quite often you've got all these fields, for example, and you want to edit them in some way. And with column selection, you can very easily select just a column of information. And there are two ways of doing that. The one way is with the mouse. You simply hold the Alt button down, and you drag the mouse, and you're ending up with column selection. But in that case, you don't stay in the column selection mode. You do column selection, then you're done with that. The other way to do it is to turn on column selection mode with a keyboard. And on Windows, that's Alt-Shift-Insert. On Linux, on Mac, the official one is Command-Shift-8, I think. I use Command-Control-Shift-C for my version. But then it stays in the column selection mode. Let me show you how that works. So where's my person class? Here I've got the fields. I don't want to make them private. I want to make them public for whatever reason. Okay? I can hold the Alt down. I can select that. And now I've selected the columns and public. Right? Just hold the Alt down. Once I go out of there, it's just normal again. Nothing's changed. The mode is just a normal selection again. Every time I hold Alt down and I select, it becomes a column selection like that. Private. Okay? All right, the other thing is, if I turn on the column selection, you'll notice it down in the bottom, down here, it says column right at the bottom, and right over there. And now it's permanently in column selection mode. So if I now move the keyboard, then it stays there, but it stays in that mode. So it is a little bit weird. Like, if I go to the front, it's all nicely lined up. If I go to the end, then it's after the last element, which is, it used to be different, but it is like that now. And should be private, right? So let's make it private. So you can imagine if you've got a lot of code that looks very similar, that you can actually get quite productive with this column selection. All right, so just make sure that if you turn on column selection, once you're done, turn it off again, otherwise you're going to get really confused with, with your selections. So I've got a little class here called fruitspec. The fruitspec has a bunch of strings. I want to add an enum in there, and I'm going to show you how I do that using this column selection and the other things I've shown you up to now. So let's go to fruitspec, Shift-Shift, fruitspec, and there we are. So find it very quickly. Here are my strings. I want to make an enum, so I'm going to make a private enum, what would I call it? Field. Okay, nice and easy. And these are going to be my enum values. So how do I get this into my enum values? Okay, so I'm going to copy this in here. Let's select them, unindent them, Shift-Tab to unindent them. I'm going to do search and replace. And I'm going to replace comma space with comma space and the new line. Okay? And replace all. Okay, so now I've made them all on separate lines. Of course, in VI, you can do that as well very easily, but this is not VI. All right. So now the next thing I'm going to do, now I can't remember the exact sequence, but we'll figure it out, is I'm going to copy this. I'm going to turn on column selection, so that's on. I'm going to put this in a bracket, all right? The brackets. Go to the front again, paste that. Oh, that should have been column selection. That should have actually worked. Let me just do that again. So it's got to do a couple of things here. There you go. So I'm going to select this, go down, select them all. Copy, go to the beginning, paste, and just need to do a few things. I want to go back to the beginning, and I want to make them uppercased. How do you do that again? Oh, no, I don't want to do that. The problem is if you're doing a talk, sometimes you forget what the shortcuts are supposed to be. There we go. So it's Command-Shift uppercase. So I've made them all uppercase over here. And there we go. So I've made all the settings here. This last one is wrong. Need a semicolon there. All right, so a bit backwards and forwards, and a bit clumsy today. Not as clumsy as yesterday, but I'm still a bit clumsy. I'm going to make a constructor. Oh, there should be a constructor here. Create constructor, which takes the name and make a field for the name, and we're done. So I've sort of done donkey work which would have otherwise been like really tedious and painful just by using column selection and creating all of this for me. All right? So just search and replace. Oh, I've got some tips for speakers. I added this because some of you might want to share with colleagues and so on. And IntelliJ is really great at doing presentations. They even have something called a presentation mode. And presentation mode basically only shows the code. So it really focuses on the code. It's like a distraction-free code. What I did was I reassigned the command option P, like the normal version. Normally IntelliJ looks like this. So normally it looked like this. Okay? So what I did was I did Command-Alt-P so that it turns it into presentation mode. And that's what it looks like. So now it's only the code. So there we go. Alt-1 will show you the project view, but other than that, it's going to be gone. The project view is gone. And all you see is the code. So this is very nice if you're doing a presentation, to reassign the Command-Alt-P, which is actually for extracting parameters, but I prefer to have it as for the presentation mode. And also what you can do, if you look at your settings, at the bottom, presentation mode, you can say how much you want to zoom by. So again, I've often seen speakers, they show the code and then they've got to zoom in every time. But here you simply say zoom is going to be whatever, 120%, 150%, whatever you need. My fonts, I made my fonts big anyway, so you can see them easily. I always want my fonts big enough so you can read it on a smartphone when I'm doing a presentation. But here's sort of also set the custom font size to 24 for the whole program. So this makes it also a bit easier to work with. All right, so I'll keep this one on. And Command-Alt-P on my machine are set up for this presentation mode. And then also what you want to do is to have different color schemes for resolutions and for different circumstances. Normally I use Darkular for my talks, but I've got different versions of the Darkular for 1080p resolution, 720p resolution, so it always is big enough so you can read it on a smartphone. But it depends where you're talking. In this room, Darkular is perfect. You've got great screens, easy to read. But if you go to the other room, you want to have a white background. You don't want to have a black background. And so it's very easy to switch, just control a back quote will do it for you. You simply go theme, high contrast, or theme, wasn't the best example, theme, IntelliJ Light, and you can very easily switch between them like that. Also, editor code style will do it as well. Now I've completely destroyed everything. Oh, yeah, there's some bugs. If you stay inside the presentation view, sometimes you have to go out and back in again for it to reapply itself to the latest versions. All right. So Control tilde will allow you to change that very easily and very quickly. All right, let's carry on with the productivity. Basic code completion, Control space does a lot of things, but it doesn't do them well. All right. So for example, here I'm saying list of string names equals new, and it shows me all the possible options. It shows linked list, it shows me array list, it shows me vector, it shows me demo, it shows me string. I'm going like, why is it showing me string? String is not a list. Like, why waste my time with string? But if you do Control-Shift space, which I actually almost always use, it only shows me the classes which are in fact lists within my project. It doesn't show me the other ones. Now, by default, if you don't do anything, if you just start typing, it uses this one. So it does the basic code completion. But if you press Control-Shift-Space, it filters them for you, and it only shows you what you actually can use within that context. So that's something that you really want to be using instead. All right. Another part which is incredibly amazing is the refactoring. This was the reason I used IntelliJ in the beginning, because it allowed me to change really bad code to be not so bad code. And you've got, for example, moving F6 will do that. Moving, rename a Shift F6, change signature. And change signature applies to methods, whereas move, I'm not sure where move applies. Rename applies in most places, but change signature applies to methods, not for other things. And you can also extract a method. So you can extract a method, select your method, or select the part you want to extract, press Control-Alt-M, and now you're extracting it as a method. But there's some restrictions. For example, and I think this is a mistake, to be honest, you can't have more than one return value. I mean, how hard is it to simply create a record and have multiple return values? It's not that difficult. But that's just the restriction they've got. Also, the block must represent a proper statement or expression. You can't have only the try and not the catch. You must be try and the catch, not just one part of it. But one of the benefits is that when you extract a method, it also shows you other code that's similar. And it says, hey, do you want to extract this as well? And make like one method out of it. It doesn't do it particularly well, though, unfortunately. So you've got to help it a bit. Like you have to help it across the road. Say, let me help you a bit. It doesn't work out of the box too well. So let's try it out. Here's an example in the PCD generator. And this is code that was from an actual project. But here's the code. Now, I want to extract that into a method. You can see it's 3 times exactly the same, almost exactly the same, just a bit different column from a database. All right, so but besides that, it's exactly the same code. So I'll select the first bit, extract method. Okay, that's get remark. Fine. Then I do the second one, and I say extract method, get remark. 2. And now it says, hey, wait a moment, we could use that also in the third extract commenters, or what is extract remark as well. And I say, okay, just do it. Fine, I don't care, just do it, accept. And replace. And now everything breaks, right? Code's broken. It says, sorry, it doesn't compile anymore. Go get remark 2, it's now got this remark twice in there. The remark is not even really used, return, it's just broken. So you need to help a bit. And what I find is, if you help a little bit to make it look more similar, then it has no problem with extracting it. It does a really great job of doing that. So for example, if I put this inside a code block, and this as well. So I just put a code block around there, and put a code block around there as well. Of course, I need to define these separately. Okay, like that. And if I now select the first one, and I say extract remark, then it says, don't you want to use it for everything? And I'll say, sure, go for it. Oh, and there we go. It's done them all correctly. So they've got once. Okay, the only thing I don't like is the name of this, but I'm willing to overlook that. Let's rename that to column name. All right? And besides that, I'm happy with it. So it's managed to. Then I can get rid of these. These are like training wheels on a bicycle. Now everything's good again. All right? So sometimes you have to help a bit. And this gets a bit tricky because you don't know how you're supposed to help. And that takes a bit of sort of practice and figuring out how to do that. There's another way you could do it as well, I think, which without the code blocks. This is just one way of doing it. And I think if you define, I think if you just made these different names, like you said, string remark 2, Okay? And I don't know if you saw this. It's actually quite clever. You can see that from then onwards, it renames remark to remark 2, but it doesn't go to the code above it. Right? So that's quite clever. Then if I do this one as well, a string remark, I rename that to remark 3, it only does the one below, not above. So that's always been like this, and it's quite clever. And if I do that, if I've got 3 different remarks, then again, I should be able to extract that, extract remark, and it should work. It should do it correctly. So if you look at that, perfect. Again, perfect, except for the name, but that's fine as well. Now, I showed you rename as F6, but I can also just do this. I can say column name, and you see the remark one is now bright red. I made it more bright than it usually is. But I press Alt-Enter, and it simply fixes it to be renamed as well. So you either do Shift F6, or you just press Alt-Enter, and it does it for you. It doesn't always work, but usually it does. Okay, inlining code is opposite of extracting. So Control-Alt-N just inlines it for you. It's very convenient, close to extract method. All right, the other thing which is very useful is the analyzer. So you can inspect your code, and you can go through entire code and say, show me all the things that I could improve. Show me where I could use Java 17 code. And just it goes dig, 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 and then poof, there you go. All of this you could improve. And it checks for the most glaring code inconsistencies that you might find. So for example, you might find enhanced switch. You could use enhanced switched or pattern variables. There are lots of different places that you could use. We could use this. Let me show you quickly how you turn this on. So I've got it at the moment set up for migration. So if I do analyze, inspect code, I've got Java 17 migrate. You have to use the JDK 17, otherwise it won't use that. Or the language level has to be Java 17, otherwise it won't show you anything. But if you run it, it runs through the code, and after a very short time, it shows you where you could improve things. So the enhanced switch, for example. And now you can do one of two things. You can either be like really lazy and just say, just do them all, migrate to enhanced switch, and you're done. Okay? I don't recommend that in general, because sometimes they make mistakes, right? It's refactoring code, and you don't want to just refactor code without actually checking what you're doing. You do need to check it. It's your responsibility. You can't just wholesale replace all local variables with var. Don't do that, please. So rather do it more deliberately. Like here, for example, they've got, this is what they produced. Now, I'm sort of happy with it, but not entirely, because I actually would prefer it to be a bit different. I prefer to do this, I want to have the equals switch printer, and then I want to return this column selection on, get rid of this. But that's not going to compile because printer is an int, so I need to have a default case which returns this CFG data 3.2, whatever it was before. Okay, so I want to use the switch statement rather than just the switch expression. Is that right? No, that was right. Anyway, so you can see that you've got the migration. And what's also nice is that they actually show it to you in line, but you need to turn it on. So you need to, inside your editor, say that in inspections you need to select what profile you want to use. And if you turn that on, then whilst you're editing, it's going to show you where you could improve things. So for example, if you look at here, you can see there's an instance of table sorter, and it says, you could use pattern variables there, and I can, so I just press Alt-Enter, and I change it to pattern variable. Done. So it sort of highlights. And I find this more useful because you don't want to just wholesale change everything, but rather you work on a piece of code, let's improve it whilst you're working on it. Keep it, make it better than it was before. All right. I'll show you one more, which is the try with resource on the receive file. So let's go to that one. It'll be down here somewhere, Java 7, I think. Try with resource is interesting because that's actually the one where they had, I think they've improved, but traditionally they had the most problems with this one, getting it right. So basically this is a try And then at the end, we say writer.close. Right? And if there's an exception, we just say print stack trace. I didn't write this code. This is a code that somebody gave me. I wouldn't do that. But here we say Alt-Enter, and replace with try with resources. And it looks okay. I think this one it got right. It's not exactly the same as it was before, but I think it's better than it was before. So I'm happy with it. But as I said, this one in particular, I've had issues with where it generated code that wouldn't even compile at the end. But I think they have improved that a bit. All right. So conclusion. If you're not on my newsletter, you really owe it yourself to subscribe. It's javaspecialists.eu /archive/subscribe. I've got readers even in Bulgaria, if you can imagine that. I've got about 1,000 in Bulgaria. Yeah, I've been doing this for over 22 years, since the year 2000. And I try to do it every month. I don't know if I'll do it this month, because I've got to do it either today or tomorrow, and I actually want to have fun with you guys. So I'm not sure if I'll do it this month, but I'll do it like on Friday or something. But you'll see lots of other things, courses, additional training, and so on. Make sure to get this if you haven't yet. And it's set to expire in like half an hour, so make sure you get it before then. Once you've got it for life. So there are lots of other keystrokes to learn, lots of other features to learn. And yeah, just learn one new one per day, and you'll get through it in 6 months. Any questions? See a hand over there? No, we need a microphone for that, sorry.
Yeah, so...
We are not ready yet. Stay where you are.
I have a function with 3 parameters. I autocomplete the function, but it doesn't put the parameters automatically. Is there a way to automatically put, smartly at least, the parameters which are in the context into the function?
Absolutely. So you can do that very easily. I've never done it, but it should be a piece of cake. You simply go and you create a new live template. All right? So live templates are here under Java. And so what you're looking for is you're looking for Sout P and Sout M. So let's go for Sout P first. So Sout P will give you the parameters. All right? In fact, there you go, dollar format will do it for you. And then you simply combine that with this one over here. So let's make a copy of this. Copy. You can probably duplicate it here. I'll just make a. There you go. So it's Sout P1. Let's do this. Blah. I'll call it blah just to make it more distinct. And then what we do is we go to the Sout M, and we take that information and add it to the Sout P. So it's going to be this. And I might have to, I think I also have to edit the variables as well to copy the code from that, because the actual code for extracting the parameters is going to be inside there. So let's go back to blah. I need to add that in there. Although I think this is going to work. I think this will work. This will be this plus that. I think that's going to work. I don't know, but we'll see. Oh, I also have to set up the applicable context. We're going to say it's going to be just Java. It should be a bit more specific, but let's see if that works. So now, if I do blah, didn't do it. I think I have to edit the actual code as well. Sorry about that? Yeah, you have to set the variables as well. So the variables are set up inside the edit variables. So you have to go and, oh, okay, so I probably have to do it for both of them. So the Sout M would be over here, edit variables. these are there ready. That one's easy. But start p edit variables. Okay, this is the one that I have to copy and paste over. So copy and go back to blah. Edit variables. Oh, it is there. Wonder why it doesn't work. Anyway, I'm not sure, but this is sort of how you'll do it. Just look at look at something which is most similar to what you want to do, and you just base it on that.
All right, thanks.
More questions?
There's a question.
Okay, one question on your extract method example. I'm not sure of this. You sort of develop an intuition while you work with it, but I had an intuition that if you just selected the if statement, it would have produced something more closely to what you wanted.
Oh, possibly. Quite possibly. Maybe. That was in I think this one here. Yeah, this one here. So let's inline this again. Okay. Back to where we had it. Remark. Oh, don't want to do that. That's the view from Office, by the way. So this, we'll just change this to be remark. Remark. And remark. So that's what we started with. You think if I do this extract method, so that should work. It should work, but then I still haven't got this part in every one of the methods, and I really wanted to have the whole lot.
Yeah.
So you're correct, but it's if I wanted the whole thing, you need to sort of massage it so that it fits properly.
Right. Okay. Thank you.
Okay.
More questions?
Well,
we're actually out of time.
We're out of time. The next one is starting
Yes,
soon.
so you can catch Heinz outside. I just have one question. Who is still using NetBeans? Anybody?
Ooh,
Okay.
that's a nasty question. I actually did a survey like a couple of weeks ago, and I put on there NetBeans, IntelliJ, IDEA, and Visual Code Studio, and NetBeans was like 11%.
Who are those people?
And Eclipse was also about 11%, and then IntelliJ was like 79%, and the rest was like 1% was Visual Studio Code. But it was kind of a little bit twisted, the thing, because because only the NetBeans crowd retweeted my poll.
Okay.
So the conclusion I have from that is that the people that use NetBeans really like it a lot. They're very passionate, and it's a great tool. Yes. NetBeans is a very, very important part of the Java world, because it's not only an IDE, it's also a whole framework that you can use for other stuff as well.
Yeah. Anybody coding on Eclipse? Well, those people can leave the conference. No, that's a joke. Thank you so much, Heinz. Thank you.
Thank you so much.
Okay, our next talk is going to be really, really useful, I guess. Well, I call the talks here. But before that, I want to ask one question. Somebody of you does TDD? And they pay you for that? Amazing. Okay, so I'm really happy that now we're going to talk about some testing tools, and Elias is here to tell us about it. So warm applause for Elias. By the way, he's the third Brazilian here. We have a Brazilian, wave cake. Thank you so much. Joy.
Cool. Let me just double check. So everything is on the screen. ID is on the screen. Web page is on the screen. Cool. Guys, thank you so much for being here. My name is Elias. I'm a Brazilian guy, surprisingly. Like he said, we have 3 Brazilian speakers here. It's insane, right? Because what is the chance to go to Bulgaria and have 3 Brazilian speakers? So, but yeah, anyway. But we are from different regions from Brazil because Brazil is extremely big. And it's me. Yeah, it's nice. If you guys want to just see if I have some useful content for you, and normally, but not normally, all the time, I talk about testing. So if you follow me on @Elias Nogueira in everywhere except OnlyFans, of course, you'll find me. It's a bad joke, right? Normally I do a lot of bad jokes as well, so please help me to. Okay. What you will learn today. 5 different tools to modernize your testing infrastructure or testing tools or testing anything in your project. I will mention other different ones you can use, but the main ones, AssertJ, which is an assertion library, super cool one. Rest Assured, that is the best DSL API or library to create integration tests for APIs. OUtility that will solve the problems of asynchronous API calls for us. So it's a combination with Rest Assured, it's super good, or without Rest Assured anyway. WireMock that creates a lot of mocks, but there's a slightly approach we can use that is called service virtualization. And we can use the power of WireMock to solve a lot of problems for our teams. And at the end, I will talk about PyTest to extend a little bit the coverage we are adding to our tests. Everything here, you have some slides. So you blah, 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 slides, blah, 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 slides. And after that, you jump into some code. And all the examples, all the code that I will show you, you have this in the end. That is my personal page. You can see it. You can have everything later, OK? If you guys want to ask questions during the talk, please do it. Because I will talk about AssertJ, and you have some question, raise your hand. You will have a question answered, thankfully, OK? Or hopefully. So AssertJ, just to give you an overview, it has 2.4K of stars on GitHub. Why I'm just showing these metrics? Because sometimes it's good because, OK, there's a lot of people using it. And liking it, actually, right? If you give it a star on GitHub, you really love it because no one does this, right? So what we can do with AssertJ? AssertJ is an assertion library. It will provide only functions to assert something. You have an actual result. You have an expected result. You need to see if the actual is equal or something like this to the expected result. And AssertJ solve some problems for assertion libraries or for the assertion methods we have on TestNG or JUnit. Even JUnit 5 that has improved a lot in the assertion part, my perspective, AssertJ is even better. Even though you're using, for example, JUnit 5, I'm using AssertJ instead of assertions from JUnit 5 because it's better, it's flexible, and adds more readability to your code. And one thing good, not one thing, there is a lot of things good, you can, in a fluent way, do all the things that is written there, like test primitive types, of course, common types like optional predicate, streams, like everything you have in Java, you can have a way to test it, to compare it, like temporal types, atomic types, etc. I will show you cool features because there's a lot of features for all these types. I will show you my 2 to 3 best features of this. So the first one is the recursive comparison. Code is not that good in the slide, but I will demonstrate this. What is a problem, what I'm trying to solve here? Normally, we have 2 different objects that are similar, right? For example, for microservices, you have your model object, and you have a detail. And they are exactly the same, but it needs to somehow like create an additional class just to transfer the object. Sometimes we need to compare. Okay, is this object equal to this one? And if you do a normal equals, what happens? I will show to you. So let's see one thing. Assert J example, cool. So here, is that okay? You guys can see it back there as well? Yeah, cool. So I have two objects. They have exactly the same data. The only different one is called simulation and another simulation detail. Cool? Yeah, assert that. Everything with assert J starts with assert that. That makes sense, like assert that thing is, or have a lot of different things, so assert that. Simulation 1 is equal to simulation 2. What is going to happen here? It seems equal, right? The data seems equal. But the equals to, what the equals does for Java class, it's the reference. It's not a data. And if I run this, even though I have exactly the data, I'm comparing the reference, and there are two different objects, because of course, it makes sense even by the name. Simulation, simulation, DTO. How I can solve this? I can break it down in a lot of steps for assertion. That is the most common thing. And it's time-consuming, it's boring. If there's one extra field, I need to add one extra field. How I can solve this? Easily. There's a feature called using recursive comparison. And for this, I will tell is equal to simulations 2. I will just run, and after that, I will explain this. What does this is doing behind the scenes? It runs without any issue. What this recursive comparison does, it sees that, of course, there are different references, but I will go field by field in both and try to compare the field value, not the reference of the class. And we'll do this magic, and it runs. Of course, I can ignore some fields, I can add extra fields, etc., but this is perfect. This will save you guys a lot of lines of code. And when we save a lot of lines of code, it's more readable, it's better to maintenance. Okay? And if I add some fields in both, I don't need to do anything in an assertion. It's done in the object itself. Cool? Second thing, there's something called soft assertions. And what is soft assertions, actually? Normally, we know hard assertions. Hard assertions are tests like, I have 2 assertions. If the first fails, the whole test fails, right? And it doesn't go to the next one or next and next and next. Soft assertions, I have a way to assert everything, like I have 3. If one fails, I still continue the assertions until it ends, and after that, I show the issues. Why is it cool sometimes? Because if I have an object, I need to see some specific things from the object, more than one, but I need to see if everything is okay or something is not okay. Soft assertions are the best ones. And doesn't consume, actually, the difference between hard assertions and soft assertions, during only the warm-up time, only the library to do this is 1 second. And if you have thousands of tests, it's only 1 second for the first time, and after that, it's running everything. So what I have here in the code, I have a soft assertion, so assert softly. So I use this reference to assert that get name is equal to John, insurance is true, is greater than that. And if I have some issue on that, the test will run till the end. How does this looks like? Where I added it, integration. This I need to do. I don't remember. No, it's not this one. Integration, custom assert. It's not this one as well. So, do you guys need a live code for this one? Or it's straightforward? Straightforward? Okay, Cool. You guys are in charge here. I'm just like trying to facilitate here. The second thing that is like, I love this feature because I do a lot of integration tests in the APIs. I need to assert a lot of different aspects of my object, a lot of fields. So this is perfect. And what you can do that is a super, super, super cool feature, it's create your custom assertion. And for example, I'm trying to create a loan system. And for a loan system, I have a minimum installments that I can apply, and I have a minimum amount I can apply, right? And if I'm not like in this rule, I can just throw exceptions and I'll say, okay, it's not allowed. But in my test, I need to do maybe some if-else or create some small abstraction to tell, okay, this is valid, this is not valid. And with custom assertions, I can create these custom assertions and try to prevent some code duplications and add more readability to it. So if we see in this slide, like I have my simulation assert that the simulation has valid installments. But how I can do this trick? Using assert.j specifically, this custom assertion. Let me remove. One thing about custom assertion, I have a specific class for that, and I'm extending this feature from assert.j. I can do this, it's abstract assert. I'm telling, okay, my class is abstraction assert, and the subject of assertion is simulation. I'm just doing some things required, and I need a constructor. But what I have here, I have one main thing. I must create this assert that to still have the same pattern of assert.j, create assert that something, and it's a builder later, so I'm returning the class. And I have here my validation. So assert that has valid installments. Okay, if actual, which is my object, the subject of assertion, and get installments is less than 2 or greater or equal to 48, installments are not like, I can't throw any fail message, okay? I'm doing the same here for the amount, and now I have as an assertion, and I can use this in all of kind of assertions that I have in my app. Okay? Again, just to show the code. I need to see more tips and tricks from IntelliJ because it needs to learning all the keys to be faster on that. Custom assertions. Yeah. So, same thing. What will happen here? I have like valid installments and valid amount. My installments are 1, so it will fail, right? And remember the hard versus soft assertions? I will run this, it failed, with the message I have there in the custom assertion. And by the way, I'm using the custom assertion first, the class simulation assert that. Cool? It stopped here because it's a hard assertion. But I can do the same as soft assertion for custom objects. But it requires me to create also an abstraction. But I will just run this. You're going to see that both will fail because both are not like attaining the requirements. And at the top is better. The first was installments. Oops. The second one was the amount. It didn't stop, it didn't halt my test. So it's continued the execution. And this is one of the most beautiful things you can do if you create custom assertions for you. How we can create custom assertions in this way is this as the same thing as we do as we did with the soft assertions. And I will use the normal assertion that I created before, but I will extend the abstract soft assertions. I will use the same subject of assertion, that is my simulation. I will do a proxy to that. And I need to implement the assert softly, which is the method name from assert.j to do it. And I just need to send it to the provider, and ACRJ internally will do all the internals to throw the message, to show the line code, show the stack trace and everything. So I have few lines of code. I can have a custom soft assertion as well. And this will help you where? To help others to understand better your code, and of course, to speed up the task creation when you need to do kinds of assertion like these custom ones. Cool? Any question? Nice. Oops, not this one. You have all the examples, everything explained here as later on in the slides, but rest assured. Who here used rest assured, actually? Few people. I love this library because you guys know Quarkus, right? Quarkus is quite famous right now. I know that maybe you guys are Spring Boot developers or knows a lot of Spring Boot, but even in my Spring Boot project, I use rest assured. And Quarkus use it by default because it's awesome too. Rest assured is a DSL in Java. It's used the keywords given when then, but it's not BDD, just to express you that the given is a precondition, when is an action, and then is expected result. So when I have, like for this example, a path parameter called name, which is alias, when I post something, I can check the status code. By the way, this is wrong because when I post something, shouldn't be HTTP OK, should be created, right? That's an issue here. But I know that most of you guys, and sometimes me, I'm doing this in the wrong way. Anyway, when you create tests with rest assured, you use all the time this syntax. So I'm just like, in a different, not in a different way, I'm just creating an object to be able to create, like creating a simulation with all the data inside. I'm sending it, and I'm trying to see if like I can assert the result. And this is the normal way to use rest assured. And this is not a good way to use rest assured. At the beginning, it's good because you're learning, you're creating tests, but after a while, you have a lot of kind of duplications on this. And I will show to you how to solve this duplication in an awesome way. So, just to explain to you, the basic usage of rest assured, let me just put here because I will need this one. I have, for example, look at this. I have a param CPF with something, and I do a get for this endpoint, the status code is not found. And the other test, I have a different than expectation, but it's almost the same. The give and the when are the same. So it's a lot of code duplication. If I need to change this approach or change the endpoint, change something, it will cost me some time to update it. So this is not that good, but this is the initial point when you're learning. The second point, what I can improve, with a specific feature from rest assured, that is the requested response specification. So what I can do for things that I can do as a precondition and things that I can expect, I can create these specifications for request or for response as a shared thing. I will have all the time this precondition and this response. So what I have here, implementing specific features from rest assured for example, all the time I'm sending this parameter. So why not making one place changeable, right? So I can have less maintenance later. The same thing for the response. I know that all the time I have this HTTP OK with some message on that. This is scale, but you can see I still have a little bit of duplications with this. What is the best way to solve this with rest assured? What I have here, let's try to look at the test first. So this first one, I have this key. What I have here, restrictions API service, query CPF with restriction. So I can see in the test, okay, I'm expecting a restriction. It's returning an object, which is message version 1, and I'm asserting that the message contains this CPF. Look how different this is the test right now. There is no given when then, there's no rest assured internals. The second test with no restrictions is almost the same. My service class will query a CPF. So probably successfully here, right? So I have this CPF, and assert that is restricted or has a restriction. It's false, because I'm expecting to have no restriction. And look how less code I have, and easier to understand. And this is still rest assured. But there's two approaches that I'm using here that is super cool. One is the service abstraction, and another one is I will auto-generate it, all the necessary code using OpenAPI. If you guys don't know OpenAPI tools, there's a library, you can generate the client code in a totally different perspective ways, for Java, for some mobile clients, even for testing. And they have an internal library for rest assured. What I need to do for that? .xml. What I'm doing first, I have the Wagon plugin here, and what I'm doing during the generated resource Maven lifecycle, I'm downloading the OpenAPI spec from this service, okay? Can be internal, can be everywhere. And I'm sending this to an internal folder. And after that, I'm using the OpenAPI generator plugin during the generated resource as well. And so in that point, that will get my OpenAPI spec, and I will tell, okay, the invoker classes is there, the API package is there, the model package is there, I'm generating for Java, and the option, the library I will use is rest assured. So all the magic that rest assured does, and we can do programmatically, it's already there. If I try to look at generated code, I already have here. So it generates all the code, and if I can see, I have for example, simulation API. It's even using the request and response specifications here internally and doing a lot of different magic. I know this, but this is super boring. But one thing super cool. I will just scroll down, scroll down, scroll down, scroll down, scroll down, scroll down. Yeah. Can you see for deleting? Normally, in rest assured, I need to specify the path. But I'm generating the client. The OpenAPI spec has the path, has the objects, knows everything. It's generating everything for me. I don't even need to play with the paths. If I change in the path, adding new parameters, etc., this code generation tool, the OpenAPI generator, will take care. And I have less maintenance, less code, less things to do. Cool. How I can use it with an abstraction model. This is the second part. So what I have here is the main. Is on the API. Client. First, I have a client where I need to build, for this example, like restriction API. I'm building the object based on the auto-generated client. This is some kind of patterns all the time this way. And after I have the API itself, the client auto-generated, I have here the same thing, but I'm returning a generic response. Because in this sense, I doesn't want to know what is the actual object. I just want this in the generic way. And what I'm doing, restriction APIs, this is the internal name that the client has, one using get. I'm using a CPF path as a path parameter. It's here. I'm sending this function to be executed. Cool? I could use here, but what is the beautiful thing? Remember in my testing code that we had one with restriction and one normal one? I could not do this with only this client, right? Because I need like two different methods to do two different tests. Or I can do more totally different tests. So what we need to do normally? Normal service abstraction. This service abstraction is super silly because it's only for one thing, but normally we create a service abstraction to encapsulate or to do a chain of actions for us, right? Like a payment. A payment is not just a payment. It calls a lot of different APIs, and after that, it's making a payment. So I could have only one method, make a payment, and calling a lot of different APIs, chaining the response and using the response as a request to the other one, etc. But what I'm doing here, I'm using the client, and inside it, I can give whatever I want as method name. So I have one query CPF and another query with restriction. I'm using the same API client, the same query, but what changes after my expected result will change. So I know that this query CPF, it's not found all the time, and I will just return false. But with restriction, I know that I have a model object, an object that is message version 1. And this will be returned. So what I'm doing here, I know that it will be OK, and I will extract the response message v1 class to this. I'm using Register uses behind the scenes Jackson library, Jackson data bind, to do this binding for us. So as soon as I'm telling the Register use this class with like do the binding for me, it will do the binding for you. So I can have like super easy tests in a super normal way without all that code like given when then and a lot of duplications. Cool? Questions? No? Okay. This was Register. This was my tips related to Register. You guys have all the examples. And our utility. This is awesome because you guys, when you test something to integration, Kafka, Redis, event source, anything, it's asynchronous, right? But all the tests are synchronous. How we can solve this problem? Through my focus here will be integration tests, of course. So we can solve with this library. And actually, the creator of Register created this library as well, because he had this problem at the beginning. So, okay, instead of putting Register, let's split in a different library just to make sure we can use in a lot of different projects, not only with Register. So our utility is a DSL that solves this problem with asynchronous systems. So everything, RabbitMQ, Kafka, etc. And we can create conditions for waiting, supporting a lot of different things, atomic structures, conditions to wait, checking fields first or checking a lot of fields. We can have integrations for tests with a Sergey. We can have a lot of things, even ignoring exceptions to just make sure, okay, sometimes I know that it will throw exception, but if I try a little bit more and wait a little bit, it will return a success for me. I can do a lot of things. And this is really easy. I will jump these slides with the examples I will show through the code. So what the problem I have here? So is this class? I just need to change the branch. Yeah, it's I have a super silly thing because I'm super lazy. I don't like to, okay, I implement Kafka and do a super big system to just show to you some like a synchronous one. I create a super silly thing. Every time that I do something in my API, I will record like some metadata. Okay, I did that. It's super common, right, when we need to audit some systems. And I'm just adding some waiting time on that. So just for you to understand, I have this event service that every time that I call this add event, I have a thread slip, a super silly one. 7 seconds later, I have this event in the database. Okay, just to illustrate how I can easily work with that. Of course, you guys will use like a system, normal system for that, Kafka, Redis, etc. Okay. So every time I do some operations in my API, I have this logged in this event database, and I will run this. And I will run this. Yeah. Credit application, it's a Spring Boot application anyway. It's not native, so it will take 4 seconds to start up. Yep. And one thing, what I will do. Wrong port. I'm using the Swagger one. For example, every time I will create a simulation, in this case, where you create a resource, I will log this in the database, but it will cost me 7 seconds to have it there. to simulate this asynchronous thing, okay? Just show to you that I will, let me just reset what I had before. Cool. I will try out. I have a payload here. I will execute. And yeah, and I will try to see, need to log in. And I use H2, so guys, don't do this. It's just examples for you to illustrate how it works, okay? Yeah, you can use H2, yeah, but you have test containers for that. You can use any database. Open event store. So it's already here, so I will do once more. Oops, no, here. Execute again, but let me just change. Execute. I will try to see, and I don't have any new data, right? And now I have a data. It's normal asynchronous system, but it's not a synchronous system, guys, please, okay? Just for illustration. I will keep saying this all the time because the example is super silly. If I try to test it, what I will have? Let's stop here. Stop, yeah. Event test. So, first, I have a super silly test that is the normal one. I will try to check for a restriction. It will add an event because I'm trying to check something. And I'm, okay, check if I have that event there in the event API or database, wherever. Of course, if I try to run this, it will take 7 seconds to have this event there. But my test doesn't know you need to wait, right? So just failed. Because it tried right away to check the event. How I can solve this? Normally, you guys have access to the repository for it. So what I will do, there's a lot of different ways. This is the easiest way to use a utility. I will try to find a key in the event table. If it's present, I will return it. And I'm using this feature from a utility. Callable, it's Boolean, of course, because it's present, true or false, right? So until it's true, when it's true, it's okay. And what I need to do, here in my second test, I'm saying I'm using this waiting time in my test because I need to tell my test, okay, wait please, and after you wait, you can proceed. So wait at most 10 seconds until event is found. Cool? And when it's found, through my database, I'm checking the event through the API. It's a super silly example, but it will illustrate you that now my test will wait for that. At least, at most, 10 seconds. So, running here. See, now, see how long it was waiting? Of course, 7 seconds at least, right? Because we know that 7 seconds, but we are waiting for 10 seconds. Super silly thing, but yeah, if I'm waiting for 5 seconds, it will fail. Because I have that delay of 7 seconds. So just to illustrate to you, you wait 5 seconds. 5. And failed. And the failure, if you guys will notice here, it's on the condition. That is awesome, but it's saying, okay, you have a condition to wait, and the waiting was the problem, not your request, subsequent request. Cool? Questions so far? No? No? Okay, no questions. By the way, this is the first time I'm giving this talk. It's brand new, so I don't know if I'm super fast or not. So I'm trying to figure out it. Examples you have, Wiremock. Wiremock, super nice tool. They are growing a lot right now. They have an awesome developer advocate. They have a lot of stars on GitHub. And what Wiremock does, for me, it's one of the most popular because I'm kind of using it a lot for quite a while. Open source tool for mocking anything. And normally, how we use Wiremock, I believe how you guys use Wiremock and how I was using Wiremock I have a stub. So when I get the URL that is a restriction, with a query parameter for that specific value, return that response error. That is a JSON with an error with a message. Cool? I'm creating a stub just to simulate, okay, I have an external restriction, an external API, sorry, that I don't control, so I will mock it. It's normal thing for us, right? If I not control it, I mock it. Cool? But you guys will do this. You mock it. The other team that is using the same service, the same API that needs the same thing, they will mock it as well. The third team will mock. All the teams will mock the same thing. And when there's a breaking change in the API, everyone needs to update that. And in my case, currently I have 17 teams. So in my case, if I do something like in this way, 17 teams need to update the same thing. It doesn't scale, it's time-consuming, it's not good, right? How we can solve this? There's some approach called service virtualization. That is more or less, you create this kind of mock structure in a server. You put in a server, and you make your different applications go to that server and check everything that is mocked. So instead of be self-contained in your project and check only for you, you add that stub in another place, and you do the request in another place. And we can do easily with wire mock. So the approach here, of course, the server right now is basically a Docker container where you can deploy everywhere. And you can use whatever way you want, locally or in a Kubernetes cluster or any kind of cluster. And I will show this to you, how we can create this to reduce this amount of time you might use in your teams to create the same thing. Okay? So first thing first, just to illustrate to you, it's also super silly, guys. I have a different, like, it's the same application, but a different branch. Like, every time that I will create a new simulation, I'm checking for a restriction. Of course, because in this sense, like, I need to get a low one. Let's check if there's any restriction. If there's any restriction, I'm denied. If there's no restriction, you can get it. And this check restriction, in this example, is an external API that I don't control. So I'm doing a super silly thing. It's super silly, but it's a REST template going through some properties to check this restriction with like the URL, port, etc. And it will check for me. And of course, on my unit test, this part will be mocked right in my test. I would mock it exactly like I was showing in the slides. And if I run this, I will just try to simulate this for you. If I run this in my app, and the port here will be different. It will be 9. Yep. If I try to create the simulation, but I'll try out, so up there, execute, HTTP 500. I not even create a good exception for that, but you can see 500 because I know that I'm trying to hit an external service that is not available or there's some issue, right? How I can solve this? What I did, you can use 2 different approaches. I will show you the easiest one. You can use the second one that is also easy, but you require some code. Wire mock, you can do everything through code, like the example I showed in the slide. You can create in Java code, stubbing everything, or you can create JSON files, and we'll do the same magic. I'm showing to you JSON files. So, for example, every time that I sending a post request to this path with this CPF, with this exactly one, the response will be forbidden. And the JSON file that will return, it's another file, that is this one, that is just CPF has a restriction. But as I have this restriction API, I'm telling as well, when I have this restriction API, I know that is internal call to this endpoint, And of course, I'm using the same value here. And respond at as 200, and with that body, with has a restriction with just a little bit more message, okay? But what I'm doing here right now, what I will do, I have a Docker file that I'm just creating on top of that the WireMock container, but right now, in 3 weeks, actually 2 to 3 weeks, they published WireMock container on test containers, right? 3 weeks, 2 weeks, yeah. They have an official image and test containers for that, so you can use test containers. I forgot to update my example. So what I'm doing here, I have a Docker file, downloading the standalone jar that will create the server. Cool. And the second thing in my Docker Compose, what I'm doing, mapping those files that I need to create this service virtualization and to reply to me. And actually, I'm using the port 8088 because it's the internal port I'm using, that restriction part I will show to you. So what I will do, I will just run it. Cool, it's running, and I can see that it has started my WireMock container, okay? It's not a container. Now I can use locally, deploy in a Kubernetes infrastructure, whatever. Remember that I just run the check through the OpenAPI, Swagger UI, and it was failing, right? It was given 500. Now that I have it, I need to just match, this is super important. I need to match the same CPF, the same key. And in my example again, I use the same key. I will run it. And it's replying to me, forbidden. That was exactly I have here. See, forbidden when I posting something for this endpoint with this value. It's magic. Now, if other teams need to use the same thing, I have a container for that. They just need to start up the container. I can even do better. I can just create a small cluster with all the mocks there. It will be available for everyone. I can remove all those. I can remove a lot of code, stub code, just creating this approach. And actually, we are doing this as well. Right now, internally at the company, we have ephemeral environments. All the ephemeral environments for the service has mocks and shared mocks, so everyone can use that. And they are just sending the test for the same path that we have. And you can do this through code, of course, instead of JSON files, because normally, sometimes, some people don't like to play with JSON files. You can just write Java code and do the same thing. Cool? Questions? Yeah, please.
Can I use OpenAPI YAML to simulate, to create WireMock endpoints, like with the JSON?
That is an excellent question. I don't know if OpenAPI generator has a library for WireMock, but this is awesome thing for Oleg, for Oleg from WireMock.
This would be great if it's possible.
Yeah, good thing, I don't know.
Thank you.
But I will ask the guys from WireMock, because they're working, try to work in a lot of different things, and I really don't know if like OpenAPI generator has a library created by WireMock or by OpenAPI tools to create those clients. Good question. I don't know how to answer, but yeah. Thank you.
Thank you, Zo.
The last tool, PyTest. Who knows PyTest here? Few ones. Yeah, cool. It has like few stars, but it's an awesome tool. What PyTest does? Mutation testing. What is a mutation testing? It's not from X-Men, but it's a concept that we will try to, this tool will try to change your code for specific conditions to see if your code will survive for that change or not. And actually, it should survive in order to be successfully. And we call this live mutations or killed mutations. Live mutations indicate that you have something to work on, something wrong. And kill it, okay, they try to change your code, and your code survive it. You are expecting those changes. And this is called mutators for PyTest. And we have a lot of different things. Mostly, based on corner case. And we have a lot of different mutators, like conditional boundary, increments, with mathematical operations and everything. And I showed you live how to do it with a super silly example. And actually, we already implemented PyTest to increase a little bit more the confidence for Jakarta EE libraries and JNoSQL libraries. So before we applied PyTest, the coverage was really good. We applied PyTest. We need to do a little bit more work just to make sure we are delivering like reliable APIs for the guys. What I will do here, PyTest, super silly example. We are going to create a test for that. Conditional. If A is less than B, A is less than B. Otherwise, B is greater than A. Cool? Classic thing, right? Like we are learning our first like programming language. We are doing things like this. It happens. And I will create a test for that. Mutators test. Cool. I will just you guys will help me, okay? So, add test. Naming correctly your test, but I will just like A, B. One thing I will do here, I need the mutators, right? Private mutators. Just because this is an excellent example as well. So what I will do, string, it will return a string. Actual is mutators. If I do my conditional 1 and 2, after that, actual is equal to, and I will just copy and paste this message, right? So, cool. And if I run this, it will run correctly. Nice. I will just do the same thing for B. So I will just flip, and it should be this, right? And I will go here, A to B, nice. I will run both tests. Both will run. If I use the feature from IntelliJ to run with coverage, 100% of coverage. Nice! My job is done, right? 100%, yay! But what I will do, just to show you, we need to configure, not configure, but we need to create a profile to run PyTest. There's a Maven plugin for that. And for that, on top of that, there's a JUnit plugin, because it should be able to change based on JUnit rules. And I'm just saying PyTest, when I do test compile, apply all the mutation coverage that you have available. Cool? What I will do? Terminal. Terminal, what is my terminal? Yeah. What I will do? MVN test compile. Let me just increase. Running the PyTest profile, okay? It will run super fast. Cool. It will generate some report here. Let me just reload. PyTest report, HTML report, and okay, it's 100% covered, but I have some problems. Can you see the mutation coverage and test strength? It's red. And if I try to take a look on it, okay, conditional boundary, survive it. What is the fault here? I don't have any test for equal. Exactly. So it's even a fault in my code, right? But I have 100% of coverage. Now you can understand how PyTest can help you to write even better tests and code. This is a super silly example, but there's a lot of different ones. And if you guys would like to see different examples, you guys can use the Jakarta project or JNSQL project for that. Questions so far? Please. There's a, yeah.
PyTest, sorry for that. PyTest is an interesting tool, but as far as I'm concerned, it works not that swiftly. So it takes time to alter all the statements in your code base, and if your project is really big, then, well, it means firstly you have to run your tests twice, because the first run and run with mutations, and, and mutations itself takes a lot of time. So my question is, have you ever used it in a real project, and how did you solve this problem?
We do use that, and for all the projects that I have the 17 teams, and it takes time. It is times we are, like say, it takes some time for us, like 2-3 minutes. It's a lot of time for during the build process, and we are like spending this time because we know that it's important for us. If there's any mutation that is surviving, we are even stopping the whole building. Okay, let's see, and the build. Let's see and let's figure out. But I know that like for Jakarta, for example, in Jakarta data that is super small, it takes like 1 minute. 1 minute for a super small project is a lot of time. But it's the price you need to pay, you know, for the quality.
Okay, thank you.
You're welcome. And just to, because I'm on time, so other modern test tools you can use as well. Test containers, Oleg's here. I'm not talking about test containers because he will be talking about test containers tomorrow, right? Yeah, raise your hand, yeah. Awesome tool. Arc unit, because you can create unit tests for your architecture and patterns you have in your project. Data Faker, that is a data generation that was based on Java Faker. Take a look, it's awesome tool. And there's one that's called right now Playwright. This is for front-end testing. From Microsoft, it's becoming an awesome tool and probably will be better than Selenium. I doubt it a little bit, but yeah, it's a super nice tool to figure out as well. And you guys, if you point your cell phone and scan this QR code, you're gonna win my slides. Yeah, not more of that. If you have any questions later, I will be here, of course. And if you guys have any feedback, I really appreciate that. So you can give me feedback. It's, oh, you can improve this, this, and that, and not punch you in the face. I will love that. Okay? Maybe I will punch you in the face, but depending on the feedback. No, I'm kidding. Thank you so much, guys, for being here, and have a nice event.
Okay, please have a seat. So we're beginning our next talk. And you see, what I like about this particular JPrime, we have really, really good friends on the stage. And I'm really, really happy that Gerrit Grunwald, actually he was on our very first JPrime, as well as Heinz. He's back, and he's going to give an awesome talk about, you see, it was about testing here. Now if you tested and found vulnerabilities, this is the next talk. So we arranged the talk, so after you find a vulnerability, what should you do? So, and Gerrit's going to tell us how to do it. So please welcome Gerrit.
Yeah, thanks. Big words. I hope I can somehow make that true. Yeah, this session is about vulnerabilities, and you might be surprised when you see the session because it's not about vulnerabilities in detail, but we will see that. My name is Gerrit Grunwald. I'm working for Azure Systems. As a senior developer advocate, I'm running the Java user group in Münster in Germany. So if there are any people that coming to Germany would like to talk at our user group, just ping me on Twitter. There's my handle, hansolo_. All right. So I'm a developer, right? I'm not a security expert. Nevertheless, I will talk about security here. And the reason for that is November 24th in 2021, there was this thing called Log4Shell. So who was affected by that in the audience? Just don't be shy. Oh, okay, cool. Yeah, same for me. And that made me think, right? Because I will be honest with you, I never thought about security, honestly. For me, it was like, I create my code, throw it over the wall, the people build it, and then ship it and gone. Well, and I'm not so young anymore. And yeah, unfortunately. So when I started with computing, or working with computers, was 1982. And so that was in the 20th century. And the software landscape was totally different at that time. So code was self-written and closed source mainly. And source code was managed in a repository on a local server. And I even remember the times when it was not even in a repository, just folders copied and renamed and all these kind of things. But that was the way it worked for us. And everything was built manually, so no build system or something in that case. Delivered on hardware, really floppy disks, and DVDs and USB sticks and these kind of things. And it ran on closed networks or on local servers. So it always locally, right, more or less. And it have been large monolithic systems. And the only connected systems have been in the government, in banking, and also in energy providers. So in the end, we had full control over the source code, right? Except you buy some libraries or some programs, but this was meant to be safe. You buy it in a store, so this is no problem. Okay. And the vulnerabilities at that time have been password hacking, really like you go to the trash can and search for some paper and, oh, look, that looks like a password, stuff like that. And computer viruses, the first ones, they spread via floppy disks or USB sticks or something like that. And it was the early days of internet hacking, right? And then time flies, and it was November 24th in 2021, and suddenly I realized, oh, it's the 21st century. So things changed a lot. We have a lot of open source software in use these days, and distributed source code management systems, this is normal, right? Nobody thinks about it even. It's just that's the way it is. We have automated build systems, CI/CD systems. It's hosted in artifact repositories somewhere on the web. It's running on public networks. It's accessible via browsers or APIs, and everything is connected. And we have no full control over the source code. But we don't care, right? I never cared about that. So today we have a whole software supply chain, which it's totally different from the last century, at least when everything started. Okay. So the vulnerabilities also changed dramatically. So these days, a really big danger is social engineering. And if you don't know what it is, then look it up. It's really interesting. And who's using social networks here? Yes. You guys look it up what it is. You will have fun. And we have malware and ransomware everywhere. And if you can get a short message on your phone and you click a link and suddenly something goes wrong, right? So this is, you don't really think about that. We might think about it, but think about your parents. They don't think about that kind of stuff. So everything that is connected will be hacked. That's a fact. And spreading malicious code is easier than ever before. And the whole software supply chain is target of attacks. And I will come to what is the software supply chain thing. So first of all, we have to take a look at some definitions. And this is the reason why I created that session. Because when I stumbled upon this Log4Shell stuff, there have been so many acronyms. The Americans are really good in creating acronyms. And I had no idea what it means. And everybody was talking because I'm working for an American company. And then people talked about all these things. And I was like, what the hell is that? I have no idea. So I looked that up. So there's, for example, CWE, which is a common weakness enumeration. And it's a community-developed list of software and hardware weakness types. You can find it here under the cwemetre.org link. And I think the slides will be made available afterwards. If not, then, and you would like to have them, ping me and you can have it. Because I have lots of these QR codes with links to that stuff, so you can read it up. It's a lot of stuff to read. So this is the first one, and you will find that sometimes. When you find a vulnerability, you will find a CWE number, right? Then there is CVE. This is the most known thing, I guess, right? So it's common vulnerability and exposure. And the idea of the CVE program is to identify, define, and catalog publicly disclosed cybersecurity vulnerabilities. Wow, that's so short. And how it looks like, for example, for Log4Shell, then the CVE code was this one, 2021, which is obviously the year, and then we have 44,228. So with this number, you can identify a vulnerability. And then you find this kind of text. You don't have to read it. This is now, it contains the versions of this library that have been vulnerable, and the versions that are not vulnerable, and it also contains some text to explain what exactly is the vulnerability of this specific version. So you can look that up, and there's also the link. And you already see in the link that there is this NVD thing, which is the next thing that I would like to explain, because this is the National Vulnerability Database. And this database is from the US government, and it contains all these CVEs and all the information about it. So if you would like to look something up and you have no idea where to start, then you go there. NVD NIST Gov. This is the NVD database, and you will find lots of information there. They even have an API. You can sign up for a key, and then you can use that in your code if you like. But it's not so easy, but you can. Then there is CVSS, which is the Common Vulnerability Severity Score. Wow. And this is always in combination with the CVE. So you have a CVE, and this comes with the CVSS. And this is in the NVD. Oh, I love it, all these acronyms. It's terrible. And then we have two different versions of this CVSS. There's the 2.0 version, which has these 3 levels, like low, medium, and high. And the strange thing here is that even if you have 0 vulnerability score, it's already low severity. And they changed that, as far as I know, in 2016, and they invented the 3.0 version. In the meantime, it's 3.1, and they gave 0, none. So that means there is no vulnerability. And then we have also, in the far end, we have now critical, right? So you will find both scores. Even in today's vulnerabilities in the CVE, you will find the 2.0 score. So just that you know there are 2 different scores. And if someone gives you 1 score, you always have to ask, okay, which is it, CVE 2 or 3, and the CVSS. And this also you can look up there. You see the link. It's again in the NVD NIST Gov, and then it's Vul Metrics CVSS. So everything's defined there. Okay. For Log4Shell, the CVSS 2 was 9.3, which was high, and the new one was critical. So, and you see the highest score, 10. And there is a reason for that, as we all know. So the question is Java secure? Who's a Java developer, by the way? That's not obvious. Who does Kotlin? No one.
Okay, one. Ruby, JRuby. No. Okay, that's good. Scala, someone? Someone heard of it? Oh, yeah. Okay, so it's Java secure. First of all, there's the Open JDK Vulnerability Group. This is one institution that should help to make it more secure. And it's a private forum of people that have been trusted members of the Open JDK community, and you just can't go there and say, oh, I would like to sign up, I would like to be part of it. No, it works differently, so they choose people, right? So it's based on trust, which is a good thing. And they receive and review reports of vulnerabilities in the OpenJDK base. Because you can imagine OpenJDK is written in Java, parts of it, right? So the code base also contains vulnerabilities, of course. And if someone reports that, then this institution will take a look at it and review it. They won't fix it, right? So they collaborate on fixing the issues, but these are not the people that really fix the issues. They coordinate releases of such fixes, and they also maintain the list of CVEs. You probably saw that when you have, you can look that up on openjdk.org. There is a list for each update with the fixed CVEs in there, if there have been some. Right, so you can look them up. And this is maintained by this institution. And they track CVEs by component because it makes sense. Right? We have now modular JDK version. So who's using JLink and create his own version of the JRE? This is really frightening. You should do that. Who's using a JRE? So what are you using in production JDKs? Nothing. Okay, too shy. No problem. So you should use JLink, right? And we will come to that. And the reason is because not all Java users use all components, so it makes sense to track them, the CVs down to components. And they also discuss OpenJDK security-related issues and so on. And they does not actively test the OpenJDK source code, this institution. But it's there, and it's good that it is there. Then we have the Java release cycle. It doesn't really sound like this is related to security, but we will see why that makes sense. So first of all, we remember these days, right? It took 4.5 years from 6 to 7, and then 3 years from 7 to 8. That was the old cadence, and then we switched to the new one, which is now much faster. We have a lot of different versions. We not only have LTS releases, which is long-term support versions. We have also STS releases, which short-term support versions. It's only for 6 months. But it gives you the opportunity to really test stuff before you come to the next LTS, and then you can use the LTS in production, and you should use LTS if possible. Okay. So you see that it switched from 3 years down to 2 years in the meantime. So the next version, JDK 21 for this year, September, we only have 2 years between LTS releases, which is even better. So you don't have to wait a long time for this LTS releases. Why is it important? Because of this. If you see the features per release in the old cadence on the left side, you see it had been 56 for JDK 8 and 91 for JDK 9. The reason for 9 is obvious because we got the module system there. But you can imagine if you introduce so many features in one release, there's a huge opportunity that you have a lot of vulnerabilities in there. And it's hard to test that. Then you see the new release cadence and you see the features that made it into the next version, and it's much lower, the numbers, which makes it more easy to test the stuff and make sure that it is secure, right? Less features per release means less potential vulnerabilities. So it makes sense. And that's the reason why the release cycle is an important part of the whole security thing within the JDK. And it's interesting that you see stuff like 5 new features. You think, wow, this is not really a lot. Depends on the feature, of course. But yeah, it's interesting that this really makes sense when you look at security. The other thing is Java updates, and this is interesting because a lot of people don't really know that there are different ways of how to update in a JDK or what is available. So first of all, there is a so-called CPU, a critical patch update. And I have to ask, who has a Java subscription here? Java SE subscription or Azul subscription? Don't be shy. Just a few. Who doesn't have? Okay, so all that don't have a subscription probably never saw the CPU release or CPU updates, because this is usually just available if you pay for it.
what it is it contains only fixes for vulnerabilities and critical issues, and that's it. Nothing more, right? So it's really safe to use that in production because you can be sure that there have been no new features in that version. When we take a look at the next one, which is the PSU, and this is the one that you can download everywhere, then this is the patch set update, and that contains the CPU, but it also comes with fixes for non-critical issues, and it comes with new features. And you can imagine if you introduce new features in an update, there's a possibility that you also introduce new vulnerabilities that not have been found yet, right? So the idea is if you pay for Java, doesn't matter who you pay for, but if you pay for it, you get the CPU updates. And if you are old enough, and remember the old days where we had the Java 8, who's using Java 8, by the way, in production? Okay, 11? Cool, and 17? Yes, great, that's good. So in Java 8, we saw on the Oracle page, you might remember this update 8U251 and 252. This is exactly the PSU and CPU thing. And then they changed the license again, like Oracle liked to change their licenses and all these things. And then they take it away. So now you have to pay for it. And then you get the CPU. And the PSU is the stuff that you can download for free. Also for all the other vendors. It's only 3 vendors. I think it's Azure, Bellsoft, and Oracle that offer CPU releases. Everybody else only does PSU. All right, so it makes sense to use a PSU. And to show you how it works, I try to visualize it. It's not so easy. We start in January. We get 4 times a year, we get the updates. We start with 1701. And we see on the upper part, we see the PSU that also contains the CPU. And the blue part is the new feature stuff. And then on the lower part, we just have the CPU updates. So if we go now to the next update in April, then from 1701 PSU to 1702 PSU, we get the new features, right, and fixes. And the 1702 CPU only contains bug fixes from the 1701 PSU. It's a little bit complex, but with this, you can make sure that you only get the fixed version from the last PSU. This means the CPU is always a step behind, but it's more secure. That's the main idea behind it, right? And that goes on then for July, and then also for October. And that's the recommendation. If you have mission-critical stuff in production, then you might want to use a PSU, CPU instead of a PSU release. So this is, but that's up to you. Just to let you know that this is available, and this could help also in terms of security for the JDK. Okay, so that means, just to give you an idea, if you don't update, and I also didn't update in the past, so the impact, if we take a look at JDK 11, so 11.0, it had 6 CVEs. Okay, then 11.01, 2, 3, 4, 5, there was only 1 fix, and then this 5 stuck in the OpenJDK release till 11.06, and then it was fixed. So from that moment on, there was nothing, and then 11.11, there was another CVE coming, and then in 11.12, 9 more. All right. And then in 13, it was all fixed again, and since then, it's okay. But if you now stick to 11, then you have 17 CVEs in your JDK, and these are not fixed. And we have 8 low ones and 9 medium. This is the vulnerability score. So you better update your JDK. It makes sense. You better check that, because I didn't check that on my machine, but yeah, since that, I do that. So if you work like that, if it ain't broke, don't fix it. Better, if it ain't broke, at least keep it up to date, right? So it makes sense. Who's doing regular updates on the JDK? On his private machine. You see? It's, yeah, do that. Makes sense, really, trust me. So the other thing is you can use modular runtime images. That's what I mentioned already. This is JLink. It's reducing the risk by removing modules, which makes sense, right? So JLink makes that possible. And removing unused modules means reducing the risk for vulnerabilities. If you don't have XML in your JDK, then there's no way to really attack it, right? Just think about it. It makes sense. And in addition, you get a smaller JDK. So if you don't use JLink, you should. It's a good thing. Yeah, hackers cannot attack what isn't there, right? So it's a really easy thing. Okay, now that leads me to the software supply chain, which for me was totally new. I never thought about it. And so it starts with us, with the developers. And usually we get our stuff from some central repository. And then we submit our code in our own repository. And from there, we build it with some CI/CD system. And once we do that, the CI/CD system also drags in stuff from the central repository, because we might have transient dependencies from other libraries that we use. And then we build some containers out of it, right? And then we put them in an artifact repository. And this goes back to the central repository. So this is in principle how it works. And then we also go to production from there. Okay, that's cool. It's a lot of things that are happening there. For us, it's just normal. But it also offers a lot of potential vulnerabilities. It sounds sometimes stupid, but this is just the fact. So you see here in the submit phase, you can have some. Then the repository itself, the build process, the packaging, the artifact repositories, and even if you go back to the central repository, you can have attack vectors where you really have something that's possible to hack. And we just take a look at some very easy things. Like a hacker can pretend to be a known contributor and just submit bad code. So it sounds stupid, right? But this is what happens, right? People do that, and it works. So you could also take over a complete account and then just inject malicious code into the repository. And from there, it goes automatically. You saw the whole chain, right? You can retrieve passwords from build scripts. I saw that. I hope nobody has that in clear text somewhere in some script. That would be terrible. And because once you get these passwords, you can just do whatever you like in the build process. And you can upload modified packages if they don't need to come from a trusted build system, right? Also, this have to make sure that this works as it should. And this is the obvious thing. Everybody from you really got at least one mail where it says, oh, this is your bank, and sorry, you have to click this link to do something, and it looks exactly like your bank account. And this is also something which happens a lot. So be careful with this stuff. That's all obvious. Who's using open source here? Yeah, everybody, right? And then you know this thing. You don't have to read it. It just contains some very important words like is provided as is, right? Without warranty of any kind. And in no event shall the authors or copyright holders be liable for any claim, damages, or liability. Right? Did you ever read that and understand what it means? This means I owe you nothing. Right? That means you create code, put it out there, and you use that. And yeah, that's a license. Yeah, it's whatever it is. I just read it. No problem. So keep in mind, and this is exactly how it works, that open source maintainers are not suppliers, right? So you don't have a business relationship with them. They owe you nothing, right? And if you use this code, it's up to you to make sure that it's secure and safe. You can't blame them, because they made sure to say, okay, I'm out. If you use that, your turn, right? Because we saw that after Log4Shell. People, how can they do that, right? Wasn't it tested? It's not their fault. But this is how it works, and that's a big problem these days. People just trust everything. Is someone doing Node.js? NPM? This is terrible sometimes, when you see what these things drag in on modules, if you check the modules folder, and yeah, you just trust it, it's fine. Then we have this other paradigm, shift left. Who heard about shift left? Probably some people, right? So that means if we have the software supply chain, in the past it was really like I described it for me, like I created the code, I put it in the repository, and then we throw it over the wall, and someone built it for us, and I don't care. And that was a problem, of course, right? Because I was not aware about security issues and stuff like that. So what it means, we have the dev side on the left, and we have the ops on the right, and shift left just means the people on the left side should take more care about security. This is the whole movement of shift left. That's what it means. It doesn't mean it's only shift left, right? So if we take a look at DevOps, then it's now DevSecOps in the meantime. That came up over the last years. First was DevOps was the thing, and then suddenly DevSecOps is the thing. But what is it really? So if we take a look at this DevOps loop, then it starts with planning, coding, building, and then releasing. This is the dev cycle, and then it goes into deployment, which is more on the ops side, operate, monitor, and then back to planning. So this is how it works. So where's security here? It's everywhere. Security belongs to all of these things. It's not left or right or something, right? Security should be all over the place to make it right. So shift left, yes, but also validate right. And what that means, I will come to that later on. So I have some facts for you that I found on the internet, which is quite interesting. This is from the Sonatype State of Software Chain report. And it says that over the past 3 years, there was an increase in software supply chain attacks by 742%, which is huge. And another thing, this is from the National Vulnerability Database, from the NVD. They also made some statistics, and you can see here on the very far, this is 2021, and they said just in this year, they saw 20,142 unique bugs and security vulnerabilities recorded. And you see that this is increasing. So software is in danger. If you don't take care about it, you will suffer from that. So another thing that I found quite interesting, Christian Grobmeier, who's one of the Log4j maintainers, he said in an interview for a German news magazine that even after 15 months, after the bugs have been fixed in Log4j, still 34% of all downloads downloaded the vulnerable version, still. Users are just lazy. They don't care. Or they don't know. That's the other thing. If you have a dependency that has another dependency and drags in the old version, you're vulnerable, right? And I found that quite interesting. I mean, this is more than a year later, after the issues have been fixed, and still 34%, a third of all downloads, are still downloading the vulnerable version of Log4j, right? And this is one of the reasons, probably. This is the transitive dependencies. That means you have a dependency on whatever library, and this library drags in something else, and you have no idea what it is. And this could be a vulnerability. And you see that is also from the Sonatype State of the Software Chain report, that 6 out of 7 project vulnerabilities coming from transitive dependencies. So, not good. And there's this other report, which is the Synopsys Open Software Security and Risk Analysis report, and they found out that they scanned code bases, and they found that open source found in 96% of all scanned code bases. And 76% of the code that they scanned have been open sourced. Right? That was open source code, which is interesting. So source code, open source is everywhere, and we just trust it, more or less. And then they also said that at least one vulnerability was found in 84% of all scanned code bases. And 48% contained a high-risk vulnerability. That's half of it. Just imagine, right? It could be you. It could be every second person in the room. And that's critical. And who's really thinking about it? To be honest, I'm not. I'm writing code. I'm not thinking about this kind of stuff. But it was shocking when I saw that. So the question is, what can we do? What's the solution for that? All right? First of all, you can update your JDK. Do that. And there are tools. There's, for example, SDKman. Who's using SDKman? Yes, cool tool. By the way, who's running on Windows here? Sorry, no SDKman for you. But yeah, SDKman supports many JDK distributions. And now I get this nice pop-up in my screen here. Oh, sorry, what's that? Okay. So it's command line only, and it's only for Linux and Mac. And it downloads and installs JDK and can also keep it up to date, which is great, right? So you can just, I don't use it, because I would like to have full control over where my JDKs are installed, so I never used it. But I like the idea. So I created my own tool, which is called JDKmon, and this was mainly because I'm lazy, and I really hated to look up the websites from the distributions and check if there's a new version available, because I don't know the release date by heart. So I created that tool, and first it just checked distributions if there are updates, and then I figured out, oh, that's nice, I can do more. So it supports more or less all JDK distributions, also GraalVM, also OpenJFX, and this is more than 20 different distributions. And it's a taskbar application. You can install it, and it will sit in your taskbar and will check in the background if there are updates available, and you can just update your JDK. And it's for Windows, Linux, and Mac because it's a Java tool. And it also checks for vulnerabilities of the OpenJDK distribution. And I use just the NVD to look that up. So, and this is how it looks like, right? So you have your window, it shows you all the versions. If there is an update, it shows you the version that is available. You can just click, and you have to install it, because I like to install the stuff in specific folders. But if there's a problem, you see this red thing with the attention mark there, the exclamation mark. If you click that, you will get this. It shows you the CVEs for this selected JDK. And you can click on the CVE and it will show you the text for the CVE, so you can look it up. So with this, you can check if your installed OpenJDK distribution is vulnerable, and even if it is vulnerable, you can't change it. You can at least look it up, what are the vulnerabilities here, right? So yeah, this is just a free tool, you can download it. I just did it really because I'm lazy. The other thing that you can do is static code analysis. Who's doing that? Awesome, that's good. So it's usually part of a code review, like white box testing. It identifies vulnerabilities in source code. At the implementation phase, right, that's very inexpensive because you can still change it easily, it's no problem. And there are standalone tools, and there are also IDE plugins. And this is a list that I found on the NIST side. This is not the best list. This is just a list that they say, these are tools that you can use, right? And you see some are free, some you have to pay for. Some have a paid version and a free version. And if you take a look at Find Security Bugs, that's in principle, it's free of charge. It's a Spotbugs plugin, extends Spotbugs, and Spotbugs is the successor of FindBugs, if I'm right. And it detects more than 400 bug patterns. It's a plugin, and this is how it looks like. You have a bug explorer on the left side. This is, I think, an Eclipse. And then it just shows you, okay, there's a problem here. You can do that in a different way. It helps you to write more secure code, which is nice. So you can use it, and it's for free. Then there are vulnerability scanners. That's a little bit more advanced, right? They detect vulnerabilities in all kinds of places, right? Not only in the IDE, in your code. And they use usually a database, or they have common vulnerability patterns that they apply to your code and check if it's vulnerable or not. And they monitor misconfiguration and coding flaws, help using only artifacts from reliable sources. It helps using only latest secure version, right? Which is also very nice. And the appearance of new packages with fixed vulnerabilities. So they tell you, oh, there's a fixed version for this package, for example. And they can update dependencies, which is great. And how they work on all these places, in source code, on the repository level, in the CI/CD system, in the artifact repositories. They can also scan that. They also can run on production, but usually that's an agent. And now I have to ask you, who is running vulnerability scanners in production here? Yeah, that's what I thought. It's typically not that many people, because they just trust, if it was okay in the CI/CD system, then it will work in production. Right? This is what usually happens. And the other thing is, there is an agent. If an agent is running at the same time, it has an overhead. If we take a look at an agent, what is an agent? Then if this is the JVM, then this is not a black box like it's here. It has all these kind of different modules, like the class loading subsystem, JVM memory, execution engine. And for example, the class loading thing is interesting. And it also comes with an API. It's a so-called instrumentation API. And this can be used by an agent. All right? Agent is just some code that is running and that can talk to the JVM using this API. And for example, what it can do, it can have a callback that every time when the class loader is loading a class, it will call back to the agent, and then the agent can do something and scan it, for example. But you can imagine that this takes time. This is really a performance overhead, at least 10%. And if you run your stuff in a cloud environment, then you have to pay for this 10% performance, right? So we have here's a list of some vulnerability scanners for Java development. We have also one, and there's Black Duck, X-Ray, Sneak, SonarCube, Privy, and there are lots more. Even there are free ones and paid ones. For example, if you take a look at Sneak Code, this is an IDE plugin from Sneak, and they have a free and a paid version. They support more than 9 languages. They have some developer-first approach, which means this is this kind of shift-left thing, right? So it's for us. It's not for the ops guys. And it's the standalone tool and also as an IDE plugin, so you can use both of that. And it also has CI/CD integration. It doesn't come with production support, right? And this is what it looks like. So it can show you where's the problem. This is a JavaScript version here. It can show you really in the code where's the problem and what is the problem. It can explain to you, this is an SQL injection and this is the problem why you shouldn't use it, right? This is the reason. This is Sneak Code. Then we have SonarCube. Very similar. They have a free and paid version, more than 30 languages, so they are really big in security, more than 4,800 analysis rules and standalone and IDE plugins available, and also comes with CI/CD integration. It looks very similar. This is unfortunately really hard to read, but it's not that important. It just shows you where's the problem, what is the problem, and why is it a problem, right? So it's the main idea, right? So they show you something if it's an IDE plugin, and in principle it works in the same way if you use it on a repository or in something else in the build process, for example. They just scan everything and give you some report, which is nice. But again, the problem is production. So we saw that problem. We also created one. This can only do Java. It can only run in production. And the idea is a little bit different because it doesn't have any performance overhead here. So we do fingerprinting CVEs. And that gives you, in the end, a fewer false positives. And because we don't have a Java agent. Because we're doing the JVM, we work on the JVM, what we did is, the JVM is loading all the classes anyway, right? So the JVM can just tell us what classes have been loaded. You don't need an agent to do that. So what we did, we just created a so-called forwarder that sits in your infrastructure, and then the JVM loads stuff, and from time to time it just tells the forwarder, here, this is the stuff that I loaded. And the forwarder then just checks for vulnerabilities. And that means we can do that in production without an overhead. And this is what we give you, either a web UI or we just offer you an API so that can be integrated in other tools. So it shows you, for example, which dependencies do you have. And then it shows you, is this dependency vulnerable or not, with the CVSS score, for example. And the most important part, and this is what is different here, we can tell you if you use it really, right? And that's the big difference. If you scan in CI/CD, we can just scan, oh, you have a dependency on Log4Shell. Ooh, that's vulnerable, right? We can tell you, yes, you have a dependency on Log4j, but we can tell you if it's used, if the JVM ever loaded the classes. If not, you are not in danger. I mean, you should change something, of course, but at least you are not in danger at that moment. So this is the difference, right? Come on. Okay, it doesn't work anymore. So if we take a look at a secure software supply chain, how could it look like? This is our supply chain, and then we usually have third-party stuff like Spring or Log4j, and we also use these big things like Kafka, Cassandra, Elasticsearch. We can use code scanners on the development side. We have different options there, and we can also use CI/CD code scans in the CI/CD system. And of course, there's also container scanning software. Who's scanning containers here? Yeah, a few. Yeah, there are tools to do that, so it's quite helpful. And so we just propose that you can use Azure on the right side, right? So this is what I mean with validate right, because we shift left, yes, that's okay. We trust the CI/CD build system, no. We validate that what the CI/CD system tells us is correct on the right side. This is what I mean with validate right. So the takeaway, and I have no idea how I'm doing in time, maybe I'm too fast. So you should follow an automated patch schedule, right, in line with the OpenJDK vendor, with the quarterly updates. So you should really do that. That makes a lot of sense. And automate application packaging with JLink. Really do that. It helps a lot. It keeps the size of the JREs really small, and it helps to reduce the, let's say, the possibilities of vulnerabilities. Watch for CVEs and libraries, right? So if you have some of these tools, and like I told you, these are free. Most of them are free. You can use them, at least on your own machine, on the developer machine. They will tell you if you have dependencies and there are vulnerabilities. Check it up, see if there are really critical things. And if there are critical things, then look for updates, right? And these tools also help you to find the updates. And use vulnerability scanners. And not only in development in CI/CD, also use it in production, because at runtime, you can introduce more code. You can load code at runtime, and you have no idea what's going on. You might be vulnerable without knowing it. So, do you need to be a security expert? Probably not, right? But you need to be aware that this kind of things are there and that they are dangerous. And it gets more dangerous every year. I never thought about it, but I saw the statistics, and it's really frightening when you see that. So with this, I just say stay secure. And if you have questions, we still have 5 minutes left. So if you have questions, you can ask them now. Otherwise, I will be around. You can ask me later on if you like. And that's it. Thanks for attending.
Not so deep.
Not so deep. We need to go deeper.
Well, not at this moment. Васко, вие готови сте? Окей. Ну чё, как?
Классно?
Ну, у нас всегда классно, да.
Ну, все просто за первое понял, что это самое важное. Очень важно. Я согласен.
Я хората си спокойно. Такие, твои, я распечатал твои эти штуки и нарезал. Значит, то, что мы разыграем в конце. Ты будешь включать?
Могу пару слов сказать, если мне надо.
Хорошо.
Лучше сказать пару слов.
Идите все.
Вот лицухи. Я пошел.
Да. Готов? Да, то будет.
Это здесь будет после доклада?
Okay. I think that we are ready to start, and I think it's the best talk to end the day because we need a deeper dive in something very, very new.
It's not a deep dive, though.
Huh?
It's not a deep dive, it's the basics.
Okay, the basics of deep dives.
Of deep dives.
Yes. Well, I'm really happy that Vasil is the second consecutive year with us, and that's why everybody likes his talks, and I hope you're going to like this talk too. So, enjoy Vasil's talk.
Hello, everyone. So, earlier today, we actually talked a little bit about convolutional neural networks in one of the talks, where we were sorting apples left and right by the different features that it had. So it's actually not a surprise anymore for you that we can do deep learning in Java. Here I'm actually going to share with you a library that is trying to compete with TensorFlow, even though that real-world implications actually show that it's still not there yet. But to get it there, it's actually up to us to, because it's open source, it's up to us to optimize, to deliver, to just get it to the good old Python level. So who am I? I'm a Java developer, like most of you. I love Kotlin. I actually started working with Kotlin and not Java. I'm a security enthusiast. Loved the previous talk. It was amazing. Like, it sounds basic, but a lot of people, and the statistics actually show that a lot of people don't think about basic security. And I actually had the chance to work into application security with OAuth to Active Directory and SAML. I had the chance to implement a Kotlin library for on the Google App Engine. Basically, it was implementation to plug in with Google App Engine. I've mostly developed with microservices. I've actually never had the chance to work in a monolith. Every time in AWS, Google App Engine, stuff like that. I actually had the chance to work with gRPC, which is coming back along. Like, I thought that people are going to forget that, and it's actually coming back. Kafka, PubSub, regular things for everyone. I love playing board games and love flying with my drone from bird's eye view. So, before we start with the agenda, I just want to say that I'm not in any way or sort a deep learning specialist. I, like you, saw the amazing development in the AI world. I saw that those convolutional neural networks, those image recognition AIs develop into self-driving cars. I saw those robots that were barely walking left and right. They were tumbling everywhere. They started running obstacle courses. They started dancing synchronously with one another. There have been many implementations, of course, ChatGPT, and I remember last year, Nadine was very pushy. No, not pushy, but he was telling everybody to start using Google Copilot, and it has been an amazing conclusion. So I got very interested to understand what's happening behind the scenes. I wanted to understand how these neural networks actually learn, how they self-develop. Because that's what everyone's saying, that they learn. You feed the data, they learn. You feed the data, more data, more data. So I kind of went into a deep dive into the basics, of course, because it's such a giant topic that 40 minutes are not even remotely close to be able to grasp it. So to understand the basics, I think my appeal here is to show you the basics, to show you a little bit about what we can do in the Java world with DL4J, how TensorFlow actually can be pluggable with DL4J as well, and to appeal to you to actually have this basic and be ready to explore more and to try it and not turn into the dark side with Python. So coming back to the agenda, we're going to talk about neural networks. We're going to deep dive in deep learning, what kind of models they are. We're going to talk about asking the right questions, because that's very important when training a model. We're going to talk about, of course, about DL4J. A little look into the Python world. Of course, we need to know what the other side's doing. I'm going to show you a demo of the most basic Hello World application for deep learning, which is using the MNIST data sets of written numbers to identify what number is written and to put out what probability that number is. So, what are neural networks? Since the dawn of time, we have been very interested in playing God. We have been very interested in creating something that's in our image. We have literature like Frankenstein's monster or the golem. And of course, the previously mentioned implication that we try to mimic how we are thinking. So it's only understandable that we call these models neural networks. They're neural networks because that's what we call the connections in the brain. And the basic building blocks of neural networks are actually neurons. When you think of neurons, you should actually think of it as a computational unit. It takes some inputs, sometimes from outside sources. Sometimes it takes them from other neurons from different levels, and adds some weights and biases, and we're going to talk what weights and biases actually are, to compute and send data to the next level, to the next layer. We're going to talk about layers again in a minute. What are weights? So weights actually mean what's the significance of the data? What's the significance of the features that the input data has? Because let's say we want to identify cats. We want to have a neural network that's going to identify images of cats. So we need to think of features that distinguish a cat from a dog, so, or from other animals as well. So basically, we want to have fur. We want to have 4 paws. We want to have cute eyes, stuff like that. And in essence, things that have those features would actually have higher weights in our input than things that don't have them. And I'm going to leave biases for a later time, because after we calculate all of those weights from the data, the neuron actually passes that to an activation function. Activation functions will decide, based on calculation of the weights and of the biases, whether or not the neuron needs to fire up, whether or not it needs to propagate more data to the next level. And we're going to talk about biases here. Basically, what biases are, those are little nuances that tip the scales left and right for the weights, identifying, basically, look at them as, hey, yeah, it has four paws, but even if it has 3 paws, it still can be a cat. So that thing can still fire for the next level. And biases give us the ability to, for the neurons to actually form very complex relations and to have variations where only the weights are, because the weights are not enough for that. So after everything is calculated, and how they are calculated, basically imagine, I didn't want to bore you with linear algebra, but it's actually big matrices that calculate the weights from each and every neuron or data that comes as an input, applies the biases, and then it runs it through an activation function, which is usually sigmoid, ReLU, hyperbolic tangents. I don't want to even go into details there, but it's basically trying to calculate whether or not the given data is enough for the neuron to fire for the next level, for the next layer. And so basically we have 3 kinds of layers. The input layer, a couple of hidden layers in the middle, and output layer. Excuse me. So basically the input layer, as we mentioned, the neurons can receive data from outside sources, from raw data, from different kinds of labeled data or unlabeled. It depends what kind of training you want to do. But that's the basic. The input layer can even serve as a daisy chain for a different neural network. You can actually use data that comes out from the output layer of different neural networks and feed them into our neural network. So why are the middle layers called hidden layers? Well, actually, in the past, a lot of people that were building neural networks were fine-tuning those weights and biases themselves. So basically, imagine them as little knobs that you can turn left and right. And that's, of course, that's going to produce a difference in the way the output layer is going to receive the data, or every other layer afterwards, from, let's say, hidden layer 1 to hidden layer 2. And these knobs were usually people would turn them themselves. Nowadays, with backwards propagation, with gradient descent, actually the neural networks are learning themselves. And there are different strategies implemented to help the neural network to better itself. And how do we identify that the neural network actually made a mistake? Well, we feed the data. But that data actually needs to, we need some sort of a way to identify that the predicted outcome of the neural network was actually within a range, within an acceptable range for us. What that means is if we coming back to that neural network that's trying to identify different breeds of cats, let's say, if we have a Maine Coon and our cost function is going to take the prediction of our neural network and compare it to the output image that we're expecting, and say, like, let's say our neural network has a 0.7 probability that this is a Maine Coon. So our cost function or our loss function would mean that we have a 0.3 error in our network. So using cost function actually helps us to identify what kind of an error our neural network produces, and this way we can calculate with the backpropagation and with gradient descent which knobs to turn. And the neural network actually does it itself, again, with linear algebra, using the gradient descent. But we're going to talk about that in a minute. Come on, connection. So what is deep learning? Well, basically neural networks that better themselves. There are many ways for neural networks to better themselves, because you have differences as convolutional neural networks, recurrent neural networks. We're going to touch base on that in a minute. But in essence, deep learning is neural networks that better themselves. So just a step backwards and talk about representation learning and what that is. And I've taken a screenshot from TensorFlow's playground, where you can actually set up quickly. I'm going to show you that in a minute. To set up quickly some different inputs, some different features that you want to look for, the kind of task, I didn't include it in the screenshot, but the kind of task you're trying to solve. And you can actually leave it, you can set up the activation function, stuff like that. You can leave it to visualize how the neural network is actually working. So representational learning is actually the neural network trying to identify features in the data and make connections between them. It's trying to make a hierarchical connection between the data, which is more important, which is less important, hence the weights. And it's actually trying to learn by organizing the data. So this is what a deep neural network will actually look like. And I was having an idea about an idea of a game so that we can visualize it more. But if we visualize this whole conference room, like this is some sort of a neural network. We have the doors, which are the entrance, which are the input of the neural network, and each one of you, each row, represents some neurons. And if people from the back just tap you on the shoulder and tell you, hey, I actually know about this news, and you decide if that news is actually important for you, you can tell it to the next layer. And it's up to you to understand if the news is important and propagate it forward. So this is what happens. So some of the neurons would actually be responsible for activating the neurons on the next level. Hence the yellowish lighting on those neurons. So what is backpropagation then? Backpropagation, in 3 words, is just retracing your steps. Understanding what made you come here, and I mean retracing your steps because in the world of neurons, not all neurons are equal given an output. In this case, these 3 neurons had no implication to activate the end result. So when we want to apply a gradient descent optimization, we actually need to further up and down the weights and biases for these neurons. These neurons have higher weight in our system. These neurons are actually more important to the end result. The other ones, let's say that actually with the cost function, this neuron was pretty close to activating. Well, we don't want that. We don't want some random data that actually comes over that limit to actually activate this neuron. So this is where we actually need to lower the weights and the biases. This is where we need to make it better, make our system better predict that this is not it. This is not the desired outcome. So it's very important to have good data preparation. There are a couple of mentioned approaches, and these are data cleaning, which from its name you can actually imagine what it is. It's just handling noise, handling missing data, handling some noise in our data, which we can identify whether or not we want to denoisify or even exclude from our data so that our network can more easily train itself. And we shouldn't forget that networks can be a starting point for other networks. So it's not a problem to teach our networks with lower data sets or higher data sets just to experiment what is best. And to experiment, you need to experiment with different activation functions and loss functions as well, which is the interesting part of deep learning for me. Data normalization, like everything, we need to have normalized data. We need to, that data need to be scaled properly. We cannot have like pictures that are very big against small pictures and stuff that are concentrated on just the hand of something and not the whole picture. So we need to have our data normalized. We also need to have feature encoding. So what is feature encoding? This means that, so we did say that we're going to look for some features. Well, in order for our neural network to properly train itself, it needs to have these features encoded into a numeric value. It needs to have it in a way it can understand it. Then we have feature scaling, which is a step further. So let's say the demo today, as I said, is going to be identify from the MNIST data set what the written number is. And the neural network is going to train itself. So in that scenario, we're trying to identify in a grid of 28 to 28 which pixels are lit. We don't need from 0 to 255 data for those pixels. We need something smaller, like 0 to 1. We need to know that this pixel is actually lit, so it's something closer to 0.8 and above, or even 1 would be the best case. So we need to scale our data into an understandable or more easily computable values for our data set. We also need to have data splitting. Basically, and that's not always, you don't always need to have data splitting because sometimes you can have unsupervised learning. But we need to have test data, we need to have validation data, and we need to have input data. So input data comes into our system. The deep learning neural network self-trains. We do that with the validation, input versus validation, cost function, yada, yada, yada. But then we need to have the test data. After we have tested everything, we have taught, or it has self-learned, the neural network has self-learned, we need to actually see how it's performing. So we need to feed it data that it has never seen. Just a newly written 3, a newly written 4. Something that we need to see that, hey, okay, you're working well with that data. Let's see how you're doing with the new one. And again, the last one as well is not always needed, sequential preparations or sequence preparation. For recurrent neural networks, we actually need to prepare the data to add timestamps or which ones after which, so that, for instance, when our neural network has taught itself, it doesn't say it says I am a speaker and not something that Yoda would say like speaker am I, something like that. So we need to have sequential data prepared and sometimes in timely manner as well. So unsupervised learning, well, almost what I just said, just don't do it. Give your neural network just large data sets of data. Which are not labeled, which do not have expected outcome. This approach actually gives us, or gives the neural network the ability to look for similar features, to look for things that actually matter, and it's the thing that it actually identifies. After you have something that uses supervised learning, you can actually use generative models which can generate data that's similar to the input data. And that's why we have stuff like ChatGPT that can generate data from everything that it was fed. And of course, it tries to generate it as close as possible to the original thing. Image construction, some of the things that you're trying to, let's say you have an app that gives you a anime face. Well, that actually, it's very simple. It hasn't learned to add an anime filter to your face. It adds some noise to your face and it tries to reconstruct it using algorithms. So what are convolutional neural networks? We've all heard of them. These are the image recognition neural networks. These are the object recognition neural networks. These are our self-driving cars. Convolutional neural networks basically work by having convolutional layers, which you stack a lot of, many convolutional layers, and like the more you have, usually they say the better they are. Again, not an expert, I might be talking gibberish. But yeah, like you have your AlexNet, VGGNet, some of the you only look once, FaceNet. Those are things that we actually fed a couple of years back when Facebook asked us to give it a lot of pics. Deep Lesion and UNet. The other ones, as we mentioned, are the recurrent neural networks. Those keep, the way I understood them are they have memory inside of them. They have temporal memory and also distance memory, which things are connected and which are not. These are the NLP models that we've actually started learning in our free time. These are group, deep speech. These things can actually, with MuseNet, they can even generate music. Like imagine that, I want like this, and you just feed it words, and it actually generates tunes for you. Google Natural Machine Translation. We have things like Google Copilot that can generate code from natural language. It's just an amazing thing, and I really urge you to explore more and to look into the different implementation and the different models. Okay, my battery might be dying. So we touched base a little bit earlier about GPU acceleration. And why are GPUs so good at this? Well, they have actually been optimized for large matrix calculations. And if we go back to the neural network, or our neural network right now, imagine that each and every one of you would actually receive information from everyone, usually from everyone, from the previous layer, from the previous row in our case. Well, that's a lot of things to add. That's the information, that's the weights, that's the bias. It's like we get matrices with thousands and thousands of different variables inside of them. And GPUs have actually been very good and always have been very good to calculate giant matrices. And, of course, floating point calculations as well, which are the basics of neural network calculation. And that's why usually you have the CUDA cores that we mentioned earlier today with the earlier talk. NVIDIA has developed that. Funny enough, I couldn't run a GPU acceleration on the M1 chip. Maybe that's my fault, but it was more hustle than positive. So I decided just to leave my demo without a GPU acceleration. So asking the right questions to train a deep learning or to let it train, we need to have some, as we said, we need to have some boundaries. We need to have a predicted outcome, and that outcome needs to be something that we want. So I want to show you something very interesting, at least for me. I saw it in a lecture from Harvard, and this is a game named Coastal Runners. Basically, as any other racing game, this is a free game, you can download it now if you want. Like any other racing game, you go around some laps, you try to finish first. You have some green tubos there that you can collect for extra points. And at the end of the game, it actually calculates where you were as a position, how much time it takes, and how many green tubos you gathered. So somebody decided to play with it and try to make a neural network play the game. And this is how the neural network plays the game. So pretty normal stuff. Goes for some green things. Actually, it's only going to go for green things. Our neural network decided that this is the best approach. This is the best way. You don't even have to finish. You just need to gather those 3 tubos to have the best score. So this is something that we didn't want. Like imagine shipping this to the end user with your game, and you see half the AIs playing over there, and you're like, what the hell is happening? So I want to touch base on a couple of other different scenarios that I read about, which were very interesting. There was an experiment to do a robot an android, if you may, that works in a warehouse. It comes in, grabs a package, goes over there, puts the package. Comes in, grabs the package, goes over there, puts the package. Well, actually, our network decided that the packages that are in front of it have zero significance to its task. So it actually started kicking them, flinging them all around the place. Well, we did tell it to just move packages. The optimization is kicking, so I guess, okay. Something else that happened, maybe you remember it, a couple years back, we had an AI that started swearing. It started just doing racial slurs in different derogatory language, and that's unexpected. That's something that we don't want. What's happening there? Well, we're talking about unexpected consequences. Sometimes our neural networks are actually susceptible to attacks. Those attacks include feeding it wrong data. Most of the neural networks that are out there, they're probably defended now. I'm actually hoping, because some of us maybe use it to generate small snippets of code. Like, imagine if somebody tells it that the snippets of code need to be generated completely differently. Oh, usually tests should catch that, hopefully. But yeah, we can talk about unexpected consequences. The final example that I want to share with you is something that happened with some of the convolutional neural networks and with the self-driving cars. There was actually a patch, and I don't know if it wasn't disclaimed if it was Tesla or NVIDIA's implementation, but there was actually a problem where a stop sign with some added anxiety data, that's what they called it, anxiety data. So that's data that basically brings little uncertainties for the AI that make it want to predict wrong data. Well, actually, they had a big stop sign. They added all those anxiety factors to the stop sign, and the stop sign actually identified it as a speed limit. The car didn't stop at the stop sign, it just completely continued over there. It was, of course, in a test environment, so that wasn't a problem, but it's actually possible to usually very easily, trick the neural networks with wrong data, or with, as we saw earlier, with not well-prepared objectives. And that's why, even though neural networks in their base are trying to be to eliminate the human factor into all of that, into the whole data preparation, data connection, we still have to have a human supervisor. We still need to have a person at the end that is responsible for checking and validating that the data is actually, that the outcome is actually what we wanted. And in the case of ChatGPT generating your code, or let's say Copilot generating your code, I'm not against it. I'm very much with it. But we all need to make sure that the code is actually something that makes sense, something that's optimized, because those things are still not very well prepared for production implications. For instance, if you tell it to generate a loop, it's always going to use the basic for. It's never like, if you want to have a stream, you need to have, oh, yeah, I wanted a stream. I didn't want a loop. So you need to make sure that the data created is always, or the outcome created is what you want. So, the O4J. Actually, I think it was 2017. I don't have my presentation notes right now. I think it came out 2017 from Eclipse. And it has been added to different projects in the meantime. But right now, right here, you can download that and play with it. You can actually have, it supports most of the neural network architecture that we talked about. It supports GPU acceleration. It has multi-layer perception for cognitive neural networks. As I said, CNNs, RNNs. It has transfer learning. So basically, while we touched base a little bit earlier, something that's able to start from a checkpoint, if you will, of another neural network. You can actually have model imports and exports. What that means is TensorFlow has an amazing giant neural zoo, as the way they call it. So you can actually import already Python-trained neural networks to your own DO4J code. It has distributed computing and, of course, natural language processing, which is in the top one, but I just wanted to mention it separately. So what it doesn't have, and that's yet, some of these are loosely supported, they have the basic functionality, but still, as I said, we need to work to improve it. It doesn't have advanced pre-processing of data. It doesn't have the model zoo. It doesn't have everything that's, of course, as I said, you can import it, but it doesn't have it created as Java things. It doesn't have automated hyperparameter tuning, which is an even better way to improve your own neural network. It supports reinforcement learning, but it's just the basic algorithms. It doesn't have the things like TensorFlow has. It doesn't have automatic differentiation, and ecosystem and community. I don't know, I learned about the O4J a couple of months ago. I don't know about you, but it's not that common for people to know about it. So why Python? Well, as we said, TensorFlow, the de facto standard, PyTorch from Facebook, Keras on top of that. Keras just is a more abstract layer on top of TensorFlow and PyTorch. And I'm not even mentioning the 5 other results that I got as a result on searching what Python has. It's extensive, it's optimized, but that doesn't mean that Java can't get there, or at least in a close margin. So before we get to the demo, I promised you guys that I'm going to show you the TensorFlow playground. And here you can actually play with different tasks, with different features, with different inputs. Like you can add noise to your data. You can reprocess what the batch size is going to be, different, as I said, features that you're looking for. Something interesting that I found, let's not use Tang. I mentioned that the activation functions usually were sigmoid and ReLU. Actually, ReLU is the thing that completely, not changes, but like, I guess, puts sigmoid into, it just completely replaced it. Because, for instance, for sigmoid, if you have this basic task, excuse my French. Let me just reload it because we're not having any. And they're promising that you can't break it. And of course, as each and every demo, I wanted to show you a classification task and how sigmoid is so much slower than ReLU. But for some reason, maybe messing up with the batch size was actually a problem. Yep. All right, so sigmoid right now is trying to build a function that's going to separate them. Like you saw that it took some time. Let's do it again. Like at around, come on now. I want you to work with what I gave you. So around 665 is what took sigmoid. So choosing the correct activation function actually has a big difference. Like this took like 6 times faster to generate it's not correct, it's not perfect because we have noise in our data. So if you leave it for a couple more minutes, it's actually going to go ahead and try to draw a line between these. It's going to try to exclude this. But like it took 6 times more to, 6 times faster to do this graph with ReLU instead of sigmoid. So it's very important to actually identify what kind of an activation function you want to have to to have better results. And you're not limited to a single activation function for your whole neural network. You can actually have different activation functions for different layers. Because, and again, I'm saying you can play with it. There's probably like concrete world data, which one's better, which one's not. But I'm going to leave that to you to find out. So, as I said, and I'm not going to write that in front of you, it's just such a small demo, but it's the hello world of the deep learning or neural network for image recognition. This is not good. Like this. Is it better? Let me just close this. So, as I said, we're going to have 28 pixels by 28. It's not pixels, but our separation of data is going to be 28 by 28. Of output number of 10, we're going to try to identify 0 to 9. We're going to have the batch size, some RNG seed, and how many iterations we want to have our neural network train itself while it's doing that. We load the MNIST dataset with train and test, just a random seed. And we start to set up our neural networks, everyone's favorite builders. You have a multi-layer configuration, which, of course, again, it's with a random RNG seed. It's not a random seed, it's the RNG seed. You have the an optimization algorithm, which in this case we're using a gradient descent. A gradient normalization, some different things, some different knobs that you can turn. The first layer that we're going to create is going to use ReLU and wait in it with Savior. And the output layer is going to actually limit itself with softmax and try again Savior. Backpropagation type standard. We don't want anything fancy. This is, again, just the hello world. If you tell ChatGPT to generate something for you, it's going to be this. I promise. Without the S outs. So if we run this thing, something interesting that I did, is that this thing initially took like 4 minutes. And it was coming out with something like 0.92 precision, which is not bad, but it took 4 minutes. So we lowered the number of epochs. We lowered the number of ins and outs. I just wanted it to mimic the way that I built the Python counterpart. And this thing actually runs for anything in the ballpark of a minute. So for a minute, we're going to have some data here, and we're going to get a confusion matrix. I'm not going to go ahead and make you write a number, yada, yada, yada. We're going to have a confusion matrix, which is a very good representation on how our neural network actually performed. It's going to show us how many times it's made an error for the 1, for the 2s, for the 3s. We're going to visualize how much our model, how good it is or bad. Of course, it's not going to take a minute in front of you guys. I promise you it was a minute. OK, let's go to the Python side while we wait for it to finish. Pretty similar stuff. We try to have the same activation function. So we still use ReLU. We still use softmax. We still have a density of 28 by 28 with 128 connections. We have 10 epochs. The batch size is a little bit bigger, but it's not. It's a little bit different. So this is how much time Python with TensorFlow takes. Let me just close this. Let's terminate it. We'll just have a clean slate and just run it. It's still compiling, it's still initializing. First epoch, second epoch, third epoch. And you can see the accuracy is very high. Of course, this is using TensorFlow. Oh, there we go. It's actually predicted that 7 is an actual 7. So this took something in the ballpark of 10 seconds, right? I don't have the S out here, the print line. But it has a test accuracy of 0.9. How did our friend in the O4J do? 84 seconds. And the matrix is very random. We have a lot of things happening with the 8, a lot of things happening with the 1. Like you can see, there are a lot of places where when it was guessing and it should have been. So I actually have one of my slides where I printed a matrix for Java. Again, 10 iterations, accuracy 0.86. And if you leave it to train a little bit more, it gets better. As I said, it gets to 90-something, but 4 minutes instead of this is 105 seconds this time. This one actually trained better. The Python one is quite better, with almost no mistakes. Again, the different numbers represent, the first one is the 1, the second one is the 2, 3, the 4 actually had some problems here, as we can see. Where's my pointer? We had some problems with the 4, with the 6, with the 7, it tried it to be a 6. So Python is doing very well and a lot faster. After the first iteration, after the second iteration, it did almost we had a giant optimization here, and the other ones were just slight iterations over it and made it a little bit better. So, some time for questions and answers, and I just want to say, again, I'm not a deep learning expert. I'm here to just try and spark some I'm trying to make you guys understand that we have it in the Java world. We need to work together to make it into a state that's optimized enough to try and be to try and work with Python. But even if we don't optimize it, we can use already Python pre-trained models and just have prototypes easily in a language that you already know. Questions, anyone? Mitya? Thank you. Oh, we had a microphone here.
Okay, thanks. Is the Java model running on GPUs? Probably not, right?
Sorry?
The Java's probably not running on GPUs, I would imagine.
No, it is.
Is it?
It works with GPU acceleration. I couldn't get it to work on Mac. It actually has an M2 release, so it is possible. It's just my incompetence.
And the Python, does that run on GPUs on your Mac?
The Python TensorFlow works with GPUs.
Yeah.
It has GPU acceleration. Yeah. Definitely.
So is that perhaps one of the reasons?
No, still same. CUDA cores are on NVIDIA, so not on A1. No, that's not the reason.
Okay,
these are both with CPU setting. So these are both using a CPU calculation instead of GPU. GPU acceleration is not acceleration. It's basically giving hardware that's optimized to do that.
Sure.
And these are both using CPU. So that's definitely, I tested it and it's not using the CUDA cores.
And the second follow-up question is, with Project Panama, we should be able to interface with native libraries more easily, I think. Is that Project Panama, I think?
No.
What is that called? I think Project Panama, isn't it improvement over JNI? So will we be able to possibly improve the performance by using more native libraries from within Java?
Well, I think in its core, we need to optimize the different models and the way they're being calculated. Because it's linear algebra at the end of the day, as we said. So if we manage to optimize the performance of the calculations in the Java environment, then yeah, we'll be able to. I'm not sure that I'm qualified enough to tell you in 1 year we're going to be better than Python, and I don't even think that we will be. But I do know that we can do it. We can not be better, but we can do almost everything with DL4J and not have to relearn Python. We can even use TensorFlow, as our colleague showed. It has a layer that gives you the ability to use TensorFlow as well. So it's quite OK to work with both worlds.
OK, we have 1 more minute for questions. Somebody? OK.
Thank you.
No more
Thank
questions?
You for your time.
Thank you so much. Thank you.
Okay.
Thank you so much. Now, please stay for the raffle. You know that if you're not in the hall, you won't win anything. Nobody will transfer it to you. It's not. So stay. If you want to get good prizes, just stay. Понимаешь, почему это хорошо?
JVM here, limiting
Excuse me.
you.
Что, вы будете на мапу?
Yeah, but...
Извиняюсь.
Много места тук.